Dalam rangka mendukung penyiapan digital talent nasional dan kesiapan inovasi bangsa, maka Telkom menghadirkan Indonesia Telecommunication and Digital Research Institute atau ITDRI. Untuk menghasilkan inovasi berdampak mega dari digital talent yang dibina ITDRI, maka ITDRI memiliki 3 pilar penting, yaitu learning, research, and innovation, untuk mendorong terciptanya talenta digital yang mumpuni. Oleh karena itu, ITDRI juga mengembangkan suatu ekosistem dengan berkolaborasi bersama Pentahelix yang terdiri dari Helix Business, Government, Helix Academy, Helix Community, dan Helix Technology Provider. Kolaborasi tersebut dilakukan dalam rangka mendukung keberhasilan inovasi, learning, dan research. Peserta atau talent digital yang akan diberi pelatihan adalah karyawan dari instansi yang sedang bertransformasi menjadi perusahaan digital. Dalam prosesnya, para talent akan melalui berbagai tahapan inovasi, mulai dari awareness, prepare, ready, dan yang terakhir adalah mega impact innovation. Journey dari pengembangan program digital Amuba sebagai Corporate Innovation Lab di Telkom Group itu sendiri dibagi menjadi 3 tahapan, yaitu incubate atau problem solution fit, accelerate atau product market fit, dan graduate. Untuk mewujudkan talent digital yang kompeten, sesuai bidangnya, ITDRI mempunyai pathway serta menggunakan metode pembelajaran yang memiliki komposisi 10% learning. Peserta akan belajar melalui video learning, podcast, dan virtual reality. Lalu 20% metode interaktif, seperti forum diskusi, dan 70% praktikal. Para talent dihadapkan langsung dengan kondisi atau situasi lapangan atau situasi yang sebenarnya. Dengan mengikuti semua pathway yang telah dirancang oleh ITDRI, maka talent digital diharapkan dapat memenuhi target yang ditetapkan oleh ITDRI, yaitu hasil riset yang applicable, talenta digital yang siap, dan inovasi yang teruji. Melalui ITDRI, kita semua dapat berkontribusi mewujudkan kemandirian teknologi Indonesia seraya membangun daya saing digital BUMN. ITDRI optimis akan menjadi pondasi yang kuat dan menjadi pelopor dalam kemandirian teknologi serta pusat inovasi bangsa dan menjawab tantangan ekonomi digital serta menjadikan Indonesia sebagai kekuatan ekonomi digital terbesar di Asia Tenggara, menghasilkan inovasi yang mega impact dan dihasilkan oleh digital talent dan dibina melalui program ITDRI.
ITDRI, from learning to innovation.
Assalamualaikum warahmatullahi wabarakatuh. Shalom, Om Swastiastu, Namo Buddhaya, Salam Kebajikan. Selamat pagi dan selamat datang saya ucapkan kepada Telkomers, partner TCUC ITDRI, dan juga rekan-rekan yang turut hadir dan menyaksikan ITDRI ConFes 2022, baik secara online maupun offline. Buat rekan-rekan yang hadir secara online, kami infokan bahwa ada kolom absensi, di mana rekan-rekan dapat berfoto dan memberikan kesan-pesan terhadap ITDRI ConFes 2022. Namun, buat rekan-rekan yang hadir secara offline,
recording in progress.
Khususnya pada hari ini, untuk dapat mematuhi dan melaksanakan protokol kesehatan dalam rangka pencegahan COVID-19 dengan cara memakai masker, dan selalu menjaga jarak antar sesama peserta selama pelaksanaan kegiatan berlangsung. Apa kabar rekan-rekan sekalian? Semoga selalu sehat dan tetap semangat. Pada hari ini kita akan bahas topik-topik dan tentunya materi yang seru banget, dan pastinya akan ada garansi nih bawa pulang materi dan ilmu baru buat rekan-rekan sekalian. Ada pepatah, tak kenal maka tak sayang. Ya, kalau mau sayang-sayangan haruslah berkenalan. Perkenalan, nama saya Natasha Gabriela Kastanya yang akan memandu acara ITDRI ConFes 2022 pada hari ini. Di mana acara ini diselenggarakan oleh Indonesia Telecommunication and Digital Research Institute atau ITDRI yang bergerak dalam membangun kemandirian teknologi bangsa Indonesia, khususnya dalam hal learning, research, dan innovation. Tidak bosan-bosannya juga saya menginformasikan bahwa ITDRI ConFes 2022 ini merupakan bagian dari annual event yang diselenggarakan oleh ITDRI dan kali ini mengangkat tema Future Back, Trouble Free, Life Happens yang akan menggambarkan bagaimana sebenarnya kondisi pasar dalam kurun waktu 5 hingga 10 tahun ke depan sebagai salah satu sinyal yang tentunya akan didominasi oleh generasi Z atau Neo Alpha yang menginginkan kondisi di mana hidup lebih mudah dengan adanya bantuan teknologi yang menjadi sinyal bagi kita untuk terus berinovasi. Dan event ini akan berlangsung dari 5 sampai dengan 16 Desember 2022, yang pastinya akan ada berbagai rangkaian acara menarik seperti virtual expo metaverse, webinar, hingga offline event. Dan tidak kalah pentingnya bahwa acara ini akan menghadirkan topik, expert, hingga partner dari TCUC TDRI yang tentunya sangat powerful untuk sharing dan berbagi kepada rekan-rekan sekalian terkait topik-topik menarik hingga 16 Desember 2022 di icc.itdri.id. Baik, sebelum kita akan memulai sesi kita pada hari ini, kami mau mengingatkan kepada rekan-rekan sekalian bahwa kami membuka sesi tanya-jawab dengan para pembahas. Jadi buat rekan-rekan yang ingin memberikan pertanyaan maupun tanggapan, dapat langsung mengisi di kolom chat box dengan format nama, institusi, tujuan narasumber, dan juga pertanyaan. Dan bagi peserta yang hadir secara offline dapat langsung menuliskan pertanyaannya di kertas yang telah disediakan dan dibagikan oleh panitia. Pada sesi pertama pada kita pagi hari ini, kita akan membahas mengenai reaction video terkait dengan robotik. Nah, video reaction ini itu berasal dari Massachusetts Institute of Technology atau MIT. Tentunya pada sesi pertama ini kita akan menghadirkan narasumber yang sangat luar biasa, yaitu ada Bapak Hari Nugroho selaku Threat Research Management, kemudian ada Mas Raden Marwan Zanuar selaku Officer 3 Sistem Evaluation DIT, dan juga dan tidak kalah kerennya lagi itu ada Mas Maulana Falitur Rahman selaku Officer 3 Surveillance Multi-Service. Dan tentunya pada sesi kita pada pagi hari ini akan dipimpin langsung oleh Mas Raymond Agramedika selaku Officer 2 Regional Enterprise yang akan bertindak sebagai moderator. Kepada Mas Raymond, waktu dan tempat saya persilahkan.
Siap, terima kasih banyak Mbak Natasha atas kesempatannya. Suara saya sudah masuk ya? Oke. Oke, bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi dan semangat pagi. Pagi. Terima kasih banyak atas kesempatannya Panitia ITDRI ConFes, dan selamat datang saya ucapkan kepada para peserta ITDRI ConFes Digital Talent dari Telkom Group dan peserta dari BUMN. Pada pagi hari ini kita akan belajar mengenai navigation and mapping for robot teams in uncertain environments. Merupakan video ulasan dari Profesor Jonathan P. Howe dari Massachusetts Institute of Technology atau MIT, yang hari ini kita akan ulas bersama ya, belajar bersama dengan para narasumber yang sudah disebutkan oleh Mbak Natasha tadi. Oke, pada pagi hari ini saya akan sedikit mengutip suatu kutipan dari Bapak Henry Ford, yaitu kita secara bersama tahu bahwa beliau merupakan founder dari Ford Motors, perusahaan kendaraan kelas dunia ya. Salah satu kutipannya adalah anyone who stop learning is old, and whether 20 or 80. And anyone who keeps learning stays young. Nah, jadi umur itu bukan tentang angka ya. Jadi umur itu adalah semangat atau spirit of learning dari kita semua. Seperti yang disebutkan Mbak Natasha tadi, background saya adalah officer dari Regional Enterprise, Telkom Regional 6. Saya tidak memiliki basic robotics gitu ya. Namun saya tetap bersemangat untuk mengikuti learning dari ITDRI ini karena memang ke depannya bisnis Telkom itu tidak tahu akan seperti apa ya. Transformasi itu terus berjalan, disrupsi bisnis itu terus berkelanjutan, sehingga kita perlu menanamkan spirit of learning pada setiap insan Telkom tentunya. Oke, pada pagi hari ini kita akan ditemani beberapa narasumber untuk mengulas video dari MIT tersebut. Yang pertama adalah Bapak Heri Nugroho. Selamat pagi, Bapak. Beliau merupakan tribe leader dari Research Management ITDRI, yang juga merupakan Direktur Akademi Telkom pada tahun 2021. Kemudian beliau adalah konsultan unit MCC pada tahun 2012. Serta beliau adalah Senior Manager GS Division Multimedia pada tahun 2009. Background edukasi dari Pak Hari adalah Teknik Elektro dari Universitas Indonesia. Kemudian beliau melanjutkan S2-nya di Sistem Informasi Teknologi dari Institut Teknologi Bandung. Yang selanjutnya adalah Mas Raden Marwan Januar, bisa disapa Mas Raden ya biasanya. Beliau adalah merupakan Officer System Evaluation Divisi IT atau DIT IT Telkom Indonesia. Beliau memiliki sertifikasi di bidang Fundamental of Deep Learning for Computer Vision dari NVIDIA pada tahun 2019. Kemudian salah satu publikasi beliau adalah Autonomous Navigation and Obstacle Avoidance for Service Robot, yang dipublikasikan di International Conference in Computer Engineering and Network for Intelligent Multimedia atau SENIM. Beliau merupakan lulusan Computer Engineering dari Institut Teknologi 10 November atau ITS. Wah, keren banget ya background-nya. Kemudian yang selanjutnya adalah Mas Maulana Valitur Rahman atau Mas Maul. Salah satu prestasi beliau dari yang banyak itu adalah juara 1 dari kontes robot beroda dari kontes robot Indonesia 2019. Di kompetisi yang sama beliau juga menyabet juara 1 juga pada tahun 2018, yaitu kontes robot beroda juga di kontes robot Indonesia. Kemudian 2017 di kompetisi yang sama beliau menyabet juara 3. Kemudian pada 2016 beliau juga merupakan juara 2 dari kontes robot pemadam api, kontes robot Indonesia tahun 2016. Dan Mas Maul ini memiliki spesialisasi bidang di Embedded System Sensor dan Actuator, serta Computer Vision dan Image Processing. Beliau merupakan lulusan dari Teknik Elektro Institut Teknologi 10 November atau ITS. Wah, keren-keren banget ya pembicara pada pagi hari ini. Tentunya semakin semangat kita dalam belajar karena memang kita didampingi oleh para expert nih ya pada pagi hari ini. Mungkin langsung saja saya share untuk materinya. Atau dari panitia ini? Izin Mbak Natasha, saya belum bisa share. Ya, siap. Sudah bisa. Oke, sudah terlihat ya. Mungkin saya langsung full screen saja. Oke, langsung saja pada pagi hari ini kita akan mengulas bersama video dari Profesor Jonathan P. Howe ini yang merupakan Professor of Aeronautics dan Astronautics dari Department of Aeronautics dan Astronautics dari Massachusetts Institute of Technology ya. Jadi pada pagi hari ini kita akan membahas tentang navigation and mapping for robot teams in uncertain environments. Kalau dilihat dari judulnya sih, ini tentang belajar navigasi dan mapping ya, yang dilakukan oleh sebuah robot gitu ya, di di kondisi yang uncertain atau tidak pasti gitu ya. Mungkin dari judulnya saja ada yang ingin disampaikan, Pak Hari, Mas Maul atau Mas Raden. Kira-kira kita akan belajar apa sih pada pagi hari ini? Monggo.
Sopo dulu.
Monggo Pak Hari dulu boleh Pak.
Oh iya. Kasih yang tua dulu.
Ya Pak.
Baik. Sekilas sebelum mulai memang ini menarik kita bicara tentang robot, itu adalah otomatis. Robot bicara tentang pengendalian. Kemudian robot itu diprogram. Yang menarik adalah ketika dibahas oleh Profesor Howe ini, bagaimana bila robot dijalankan di tempat yang kita tidak tahu, yang sesuatu yang tidak bisa kita duga, tidak bisa diprediksi. Artinya istilahnya sesuatu yang tidak kita ketahui sebelumnya. Maka disebut dengan uncertain environment. Nah, tantangannya malah di situ. Kalau sesuatu yang pasti sudah pasti gitu ya, robot bisa diprogramkan untuk menuju ke suatu tempat, bergerak ke arah mana yang kita inginkan gitu ya. Paling variasinya nggak terlalu banyak, maka bisa diprogram. Tapi ketika berhadapan dengan situasi yang tidak kita kenal, maka robot atau sekelompok robot, nanti kita bicaranya tentang sekelompok robot teams ya, itu bisa saling memberikan informasi, saling belajar, mempelajari kondisi terbaru. Kira-kira seperti itu. Mudah-mudahan akan menarik nanti ke depan. Terima kasih. Monggo.
Siap. Terima kasih banyak Pak. Izin dilanjutkan dulu Pak ya.
Basically running on adrenaline at this point. It's a lot of exciting things going on. Anyway, I want to talk to you today about our work on navigation and robotic teams. Basically, a lot of the work we do is team-based, so a lot of those issues, a lot of issues at the single vehicle level that we address as well, but we'll also be thinking about multi-vehicle level. I mentioned the uncertain environments in part because we're thinking not just about roles in which we're either free man. And so you'll often hear people talking about things like Waymo go out and actually map the world and they're driving. Well, we're thinking about things that are sort of partially known. There's a point of time. In terms of the different kinds of things we do, these are actually applications I'm not going to say more about, but I'll give you some of the different things that we do. One of them has to do with a giant lab that we actually have. We were fortunate to build on campus, actually, basically this one right here. This is actually just half of the lab. These quadrants are actually flying around. They're actually hexes doing information flying using sort of relative navigation as a mechanism to figure out where they are. The floor looks a little bit weird, but it's intentionally dirty. They're actually using the markings on the ground as part of the localization. If it looks like star maps, it's sort of they are. Actually have cameras on looking down. So this is sort of
uh, izin mengulas sedikit ya nanti untuk ditanggapi para pembicara gitu. Ini adalah research yang dilakukan di ACL, yaitu Aerospace Control Laboratory. Gambar pertama itu adalah VAO based formation flying. Saya juga sempat cari tahu sebelumnya, yaitu adalah visual inertial odometry ya, VAO itu. Jadi seperti drone gitu, robot tersebut terbang gitu dan membentuk formasi tertentu untuk berkomunikasi dan bernavigasi. Lalu yang kedua adalah social acceptable navigation, itu robot yang bisa berjalan atau surrounded by people gitu ya. Secara sosial dia bisa seperti kita ya, seperti manusia menghindari collision gitu ya. Untuk tidak bertabrakan dengan orang-orang yang berjalan di sekitarnya. Lalu yang ketiga adalah actor critic knowledge. Ini kalau saya simak tadi itu tentang sharing ya. Sharing dari kedua robot yang memiliki kamera sendiri, gitu nanti mereka bisa switch informasi yang ada dari kedua belah pihak gitu ya. Lalu VR Robotic Test Bed itu adalah combining flying robots secara visual, gitu. Jadi memvisualkan dari hasil yang sudah ditangkap kamera dan berbagai sensor tadi ya, untuk diproject divisualkan ya dengan proyektor dari ceiling atau dari atap gitu ya, dipantulkan ke bawah. Terus kemudian landing on moving platforms, ini ya drone tersebut atau robot tersebut bisa juga mendarat di suatu objek yang bergerak gitu. Lalu yang terakhir kurang lebih collision avoidance, yaitu sebuah robot yang dijalankan di antara orang-orang tersebut tadi dibilang baru bangun di jam 3 pagi, jadi arahnya tidak beraturan gitu ya di laboratorium tersebut gitu. Terus robot tersebut berusaha menghindari tumbukan, kurang lebih seperti itu. Mungkin ada komentar dahulu dari Mas-mas ini ya, Mas Maul atau Mas Raden atau Pak Hari, monggo.
Ya, terima kasih Mas Raymond. Mungkin izin untuk saya memberikan komentar terkait dengan video yang telah ditampilkan tadi. Ya, memang untuk navigasi dan mapping ini salah satu hot topic ya kalau di robotik. Apalagi ini tidak hanya satu robot, tapi untuk robot tim atau beberapa robot yang bekerja sama untuk melakukan navigasi dan mapping. Kalau di robotika biasanya kami menggunakan robot operating system. Di dalamnya ada salah satu package yaitu SLAM untuk simultaneous localization and mapping. Jadi robot kalau kita biarkan begitu saja tanpa mengetahui lokasinya di mana atau posisinya di mana saat ini, maka akan kebingungan juga. Nah, untuk itu salah satunya kita menggunakan odometri, menggunakan data posisi. Kalau robot beroda kita menghitung perputaran rodanya ke arah mana, jadi kita bisa tahu posisinya saat ini. Nah, untuk yang bio-based formation flying ini menggunakan visual odometry, menggunakan marking yang telah mark di lantainya, kemudian drone-nya akan menggunakan kamera dari atas untuk melihat markingnya, dan sehingga dapat melakukan formasi sesuai yang diprogramkan. Kemudian untuk yang kolom berikutnya yaitu terkait dengan navigasi di environment yang yang unknown atau masih belum diketahui. Ini selain kita perlu mapping, perlu kita prediksi juga trajektori atau prediksi orang ini mau jalan kemana. Jadi selain navigasi robotnya, untuk kita bisa melakukan mencari path yang tercepat, kita juga perlu memprediksi tumbukan dari orang-orang tersebut. Kemudian yang knowledge sharing, ini seperti yang tadi disampaikan tadi, kita sharing posisi robot juga terkait dengan visualnya yang di-capture oleh kamera robot tersebut. Kemudian ada juga yang VR tadi yang diproyeksikan dari proyektor di atas ke lantai, kemudian robotnya dapat atau drone-nya dapat mengambil item-item yang telah diproyeksikan tersebut. Untuk yang berikutnya terkait dengan landing di moving platform, ini tadi ditampilkan ada seperti mobil kecil yang berjalan, kemudian drone-nya dapat landing walaupun mobil tersebut berjalan. Nah, ini perlu diprediksi juga kecepatan mobilnya tersebut seperti apa sehingga drone dapat landing dengan tepat. Kemudian untuk collision avoidance menggunakan deep RL, ini pengembangan dari yang sebelumnya terkait dengan nomor 2 itu video kedua menggunakan deep learning agar lebih presisi serta dapat dilakukan lebih cepat untuk prediksinya. Mungkin berikut yang dapat saya sampaikan, Mas Raymond.
Siap, terima kasih banyak Mas Raden atas tanggapannya. Mungkin izin dilanjutkan dulu ya, rekan-rekan videonya.
Things that we do. One of them has to do with a giant lab that we actually have. We were fortunate to build on campus, actually, and especially this one right here. This is actually just half of the lab. These quadrants are actually flying around. They're actually hexes doing formation flying, using sort of relative navigation as a mechanism to figure out where they are. The floor looks a little bit weird, but it's intentionally dirty. They're actually using the markings on the ground as part of the localization.
Izin dipercepat satu slide tadi ya, sudah ganti slide-nya. Terus.
One of them has to do with navigating. So it's sort of how do we move around quickly in the types of environments? And again, I say unknown. Typically, we'll work in a domain where we might know where we are, but we really have no idea where anything else is. And in particular, like I said in the moving robot case, we might have a sense of what's right around us, but we don't have a bigger sense of what's going on the larger scale. So of course here you want safety, you want tractability because we're going relatively quickly. You want to make sure that this thing can be computed fast. Other kinds of questions whenever you're doing learning, and what comes up is how do you certify anything? How do you know this is actually going to work? So it's a big question having to do with the learning techniques. So we'll talk a little bit about our attempts to address those questions. One of the questions that has to do with a lot with the exploration, well, the delivery robots is just how well do you actually know the environment you're doing delivery? And so one of the questions we're looking at here, it has to do with contextual or semantic relationships between objects and how those are used to actually help us plan well beyond our actual knowledge. And the point being that semantic labels actually give you insights on how things might be connected in the world, and you can take advantage of that in a planning framework. So we'll get to that in a second. The last thing has to do with the classic question I have for any time you're doing multi-robot stuff, is just to what extent do they actually agree in the language they're actually using to communicate? And if you've probably experienced this on the phone where you end up, we're talking to someone you maybe not met before and you realize you're having a whole conversation, then you were misusing the same words and you actually agreed on something, but you actually had a different meaning of what those words meant. It happens all the time with humans, and it certainly can happen with robots. And we'll get to an example of the type of issues we have here. The bottom line is that what you'd like to be able to do is just share information between the robots. They have different partial views of the world. You'd like to be able to fuse them, but before you can do the fusing, you have to make sure there's an alignment process. It essentially ends up like a big permutation. I just need to make sure that we are in agreement before we fuse on that we're actually talking about the same thing. Once that alignment is done, then we can do a fusion. You'll see a lot of people talking about fusion. You'll see thousands of papers about these algorithms called consensus. They've already presupposed an alignment vector. They've already dictated ahead of time what that alignment was. And once you've done that, you can just fuse away. In the real world, you don't know what that vector is going to be. And that's the question we're trying to address. So it's align first, fuse second. But again, this has to be fast. And so again, a lot of this has to do with just how quickly you can actually do this process. All right, who's in charge of time? Because I'll just talk forever. So that clock says 10 past 2, and we're ending at 35, right? Cool. So fast and safe planning, and again, this is a really redacted set of slides, so I'm going to hesitate to even...
Oke, di pause dulu mungkin, mundur sedikit. Stop. Oke, jadi disampaikan dari Profesor Jonathan tadi ya, challenges in multi-robot anatomy, jadi apa saja yang ingin dipecahkan dalam penelitian beliau ya di laboratori beliau, yaitu yang pertama adalah unknown environment, kemudian learning techniques, atau apa algoritma yang digunakan. Kemudian yang ketiga adalah plan sensor horizon, planning dari sensor yang akan diterapkan, dan kemudian fuse gathered in one robot gitu ya. Jadi menggather semua fungsi tersebut dalam satu robot. Mungkin ada tanggapan terlebih dahulu. Monggo Pak Hari atau Mas-Mas, silahkan.
Ya, izin menanggapi Mas Raymond.
Siap, Mas Maul.
Untuk multi robot ini memang challenging ya, karena kita memanage lebih dari satu robot dan harus ada komunikasi dari satu robot ke robot lain gitu. Jadi kalau pengalaman saya untuk komunikasi antar robot ini bisa ada beberapa teknologi yang dipakai. Bisa menggunakan yang teknologi Wi-Fi. Jadi kita dulu di tim robot itu menggunakan teknologi Wi-Fi yang 5 GHz untuk komunikasi pengiriman datanya ke control station istilahnya. Dari control station itu nanti disebarkan lagi ke masing-masing robot, dikumpulkan lalu hasilnya disebarkan lagi ke masing-masing robot gitu. Makanya yang poin bawah ini ada how to fuse representation gathered by individual robot, ini di-align dulu observation-nya, setelah di-align, di-fuse, baru hasilnya infonya dikembalikan ke masing-masing robot untuk pengambilan keputusan gitu. Lalu juga karena ini tadi unknown environment ya, jadi kita nggak tahu environment itu ada apa aja, diperlukan reaction time yang cepat. Nah, untuk reaction time yang cepat itu perlu juga istilahnya computational force yang mumpuni gitu, nggak. Jadi istilahnya kita nggak pakai komputer yang kacangan untuk mengolah model deep learning yang sudah dimasukkan ke dalam robot itu. Dan biasanya juga perlu bantuan graphic card untuk mengolah model tersebut, karena dengan graphic card biasanya bisa diaktifkan untuk parallel computingnya, jadi bisa lebih cepat gitu.
Siap. Well noted, Mas Maul. Terima kasih banyak insight-nya, Mas. Mungkin izin kita lanjutkan terlebih dahulu ya, karena waktu yang terbatas.
Actually do this process. All right, who's in charge of time? Because I'll just talk forever. So that clock says 10 past 2, and we're ending at 35, right? Cool. So fast and safe planning, and again, this is a really redacted set of slides, so I'm going to hesitate to even say we're going a lot of depth here. I'm going to show some videos, talk about concepts. Any questions that come up, just let me know. Most of these have links like this, so you can get from GitHub with the paper themselves. A lot of these papers are in archive. This is actually just presented at IROS in wherever that was last week, possibly Japan. It may have been Korea. I'm not sure where the students went. So here we're interested in, again, the classic problem of can you fly quickly in a not particularly well-known environment? You might have had a map of what it looked like before an event happened, but then maybe an event happened and now you don't have a really good sense of what you're going to be flying into. So for a bunch of different sort of operational reasons, we'd like to be able to do this quickly, but of course we want to make sure we're doing it safe. And if safety requires you slow down, then you slow down. But if you're able to speed up and go quickly, you should be able to. And so the classic problem that you have here is the world sort of ends up looking like, there's a known piece, a piece that might be, in the sense that, well, there's going to be sort of occupied known, free known, and then unknown. And I'll talk about the colors in a second, but the blue here, the cyan, ends up being the sort of the unknown piece. The orange ends up being the occupied known, and white in these pictures are effectively the known free. And the classic difficulties, what I'd like to be able to do is to plan a path. And I'm at A, I'm trying to go to E, and I'd like to be able to just plan a path from A to E and optimize with some cost function like time and just get there as quickly as I can. If you just assume the world is known, you just plan a path, this red thing, and just say, I'm just going to plan that path and be really optimistic about what's going to happen. Of course, the problem is that maybe something out there you don't know about, which is this sort of unknown blob up here, which is on that path. And of course, I show it as being here, but it could have been right here, right at the boundary between known and unknown. And again, keep in mind, we have limited field of view sensors. We don't know what's out there. We're flying about 3 or 4 or 5 meters per second. We can only see about 3 or 4 meters in front of us. So we're going to get surprised a lot, okay? So we're going to be flying along, optimizing for time along this red trajectory, and all of a sudden, sort of right at that boundary between known and unknown, something appears. And a robot throws his hands up in the air and says, don't know what to do, you need to have a backup plan, right? So one backup plan is you just don't do that, right? You just stay in the known space. You just sort of puddle along like this, and you get to E, and you hope everything's great. By this point, the horizon recedes, and you just keep going slowly like that. So you got the optimistic but completely unrealistic, safe but super slow, and this basically ends up just being sort of fast and unsafe, okay? So the gap then is how do you actually sort of get the fast and safe trajectories? And ideally what we're going to end up doing and what we actually end up doing is creating sort of two paths, the red, which is optimized under the optimistic assumptions. But at the same time, we have a deviation point R, which is then at what point we basically decide to bail and actually go to a backup plan, which is this sort of path RF, which is our safety plan. Now what we actually publish is ARF. We publish this. We go from here to here to here. We say that's it. And if you don't hear from me again, that's what you follow. Right? And the planner then obviously is recalculating this as quickly as it can, but you're running an online optimization. If you run optimizations like this, you actually don't know if they're going to end. It's a stochastic end time. So one of the failure modes is this: the next time you run this optimization, it simply doesn't finish in time, because this is a clock cycle. We're churning around as fast as we can, and if your optimization ran and didn't succeed, that's considered a failure. Another failure is that there's a big obstacle sitting right here that we knew nothing about. Our red line's plowing right through it. And we get hugely surprised, throw our hands up in the air, we see it, but it's just jam on the brakes, and it's like, now what, right? And the point being, you need to know this information about this point, at which point you can bail and leave, right? And that's basically what we're doing. Now, the trick is that, this is computationally difficult, and what I've just done is sign us up for not just one computationally difficult problem and now doing two, because I need to solve the red path and solve the green path. And the question is, how do you do all this and actually get it done in time? And that's really what the trick was, to actually figure out how to do it efficiently and how to get efficient heuristics, which is what this graph ends up looking like. I'll get to this picture in a second. It's right here. So if you've seen these types of optimizations before, you'll recognize a lot of this junk. This is a massive mixed integer quadratic program you run. It's massive in the sense that lots and lots of variables, but it's really short, right? In the sense that it's not looking that far into the future. So it isn't that hard to actually solve. But there's a big challenge that shows up, is that this is all done in discrete time, which is essentially picking these green dots. But these green dots are, the blue dots. The blue dots are actually described as a location in space, but you're still missing the notion of time. And so what you actually do is separate the optimization out. One is a space optimization, the other is a time optimization. You separate the two out for simplicity, okay? But then you have to do a second step that says, okay, I've agreed to go through these blue dots, but now I have to decide how long it's going to take me to get to each one of these blue dots. And that's the real question. What my student Jesus was able to figure out was that basically you could do essentially a line search. So
Pause
the
dulu,
first calculation.
Oke, mungkin karena waktu yang ini ya terbatas, kita tadi ulas sejenak bahwa ini akan diadakan atau sudah diadakan oleh profesor tadi ya, tentang penelitian tentang fast and safe trajectory ya, untuk bagaimana membuat robot dengan lintasan yang fast gitu ya, yang dia bisa melaju dengan cepat dan safe gitu ya, dengan berbagai himpunan tadi ya, untuk menggambarkan itu. Ada unrealistic, ada safe but slow, dan fast but unsafe gitu. Kemudian di-generate dengan algoritma tertentu untuk membentuk suatu perkiraan lintasan tadi ya. Mungkin ada yang ingin diulas dahulu, monggo. Mungkin Pak Hari, silakan Pak.
Monggo, silakan. Makasih. Jadi ini memang tantangan dari dunia robotika terkait dengan kondisi yang tidak kita prediksi sebelumnya. Jadi kalau kita melihat perencanaan yang kuat antara tadi perjalanan dari A ke E, jalurnya sudah kita ketahui pasti, maka bisa dibuat jalur yang bisa diprediksikan. Habis ini ke sini, beloknya ke sini, sudah diprediksikan. Tapi tantangannya ternyata kita masuk ke arena yang tidak diprediksikan. Tadi yang disampaikan adalah perjalanan dari suatu drone melalui daerah-daerah yang bencana, mungkin seperti itu, sehingga dia melalui daerah-daerah yang tidak bisa diketahui seperti sebelumnya. Nah, memang akhirnya tantangannya adalah pada saat memasuki arena yang tidak diketahui, maka peluangnya, kemungkinannya, variabelnya luar biasa besar. Itu yang makanya disebut, akhirnya dibangun suatu algoritma yang disebut dengan massive mixed integer quadratic program. Sudah quadratic, mix, dan masif. Datanya masif. Apapun kemungkinan akan dibuat di situ. Terbayang bagaimana cara mengendalikannya, bagaimana cara memprediksi suatu kondisi yang tidak kita ketahui sama sekali. Di sini si robotnya akhirnya berjalan dengan beberapa kemungkinan tadi yang disampaikan. Mau cepat tapi dengan resiko, udah pasti nggak, itu bukan yang diinginkan. Yang kedua adalah lambat untuk memeriksa semua kondisi, tetapi terlambat sampai di tempat. Itu juga tidak diinginkan. Jadi kombinasi dari dua kondisi tadi. Nah, tantangannya sebenarnya dua hal. Pertama, bagaimana itu bisa membuat komputasi secara cepat dengan semua variabel tadi. Jadi perlu mesin yang cepat ya dalam hal ini. Algoritma yang efisien untuk menentukan keputusan. Dan sebenarnya yang menarik adalah, saya belum tahu apakah ini udah di sesi ini atau setelah ini, sedikit lagi sebenarnya. Sedikit lagi setelah ini, nanti kita lihat ya. Sebenarnya ini bisa memanfaatkan dengan model kelompok tadi. Jadi kalau robot sendirian sulit untuk memprediksi. Tetapi ini malah tantangannya, keunggulannya juga. Ketika sekelompok robot, maka setiap robot bisa berbagi pengalaman. Ketika ini terjadi, si robot ini menemukan kondisi ini, maka ilmunya nanti akan dibagikan. Itu nanti coba ya, kita lihat dulu. Saya tadi tidak terlalu perhatikan apa sudah masuk ke sesi itu. Tapi sebenarnya sudah mulai muncul peluang-peluang untuk menyelesaikannya. Kalau dilihat dari tantangan pertama adalah massive mixed integer quadratic program, maka harus membangun sistem komputasi yang luar biasa cepat dengan banyak masif variabel yang harus dikelola. Itu tantangan pertama. Mungkin dari saya sekitar itu dulu. Mungkin kalau ada masukan dari Mas Maul, apalagi Mas Edfried Ferdiansa.
Mungkin izin
ini menarik
di next dulu Pak ya. Ada penjelasan lebih lanjutnya nanti. Siap. Terima kasih Pak Ari.
Kita lihat.
To find the blue dots is actually pretty straightforward. We can do that really fast. The calculation to figure out how to distribute time along those blue dots is actually pretty complicated. But you can imagine that if I try to get between those blue dots really fast, you end up zigzagging all over the place, and the vehicle might saturate its actuators and not work particularly well. You go too slowly, you're probably not optimizing the performance that well. So we actually do a line search, and basically what happens is, say, time instant k here, you might search and choose a particular value and realize it fails, choose another value, it fails, another value fails, and then you find one that works, and we're just basically searching along here looking to see what types of values might work for time distribution. The cool thing is that each one of these is actually really fast. Each of these is only about 4 milliseconds, and we can do a bunch of these, and then there'd be a total of only about 15 millisecond calculation, which gets us to a fast enough cycle time for the entire system that we can actually run all these optimizations in real time. And actually, so this is all running on board the vehicle. We actually are flying with an i7, a Nook on board doing these calculations. So we run all this optimization and run that line search, and the total amount of time for this is, like I say, about 15 milliseconds. So you pull up some tests and you start doing the ubiquitous forest. This is sort of a standard benchmark problem for this type of work. You download a bunch of other optimizers and see how they're doing. And again, we're sort of running both of them. One is doing about 15 milliseconds, the other is about 20. So we're designing both parts of this graph in about 35 milliseconds. Again, fast enough for what we're doing here. You compare it, this is us down here, FASTER, cool acronym. You compare it with all the others, and in this particular case, we're just comparing distance traveled and success rate. And for all the others, we're able to download and run their code against this application domain. Oops, what happened there? Run button, go back. Okay, now we're going the wrong way, go back. We were as successful as others. Of course, this was actually us as well. This is our previous work, and this is the next work. So the best competitor to our current work was our previous work, but we were still better than all the others in this case. So this is the kind of thing you would see when you're flying. This is working on, this is sort of a bunch of different images showing you the world. We're actually flying around in an office environment which have a lot of what we call bug traps, right? You fly into an office, you can't get out of it, you need to turn around and come back out. And that's actually what it did just there, which is actually, and what it's creating here is a very localized map of the world. It doesn't have a big map because the representation scale is complicated here. If you make a big map, it's hard to update it. It takes a lot of time to do that. So it keeps a little map of about sort of, in this case, about 10 meters around here. Each one of these are voxels, right? And so it sees stuff, it fills that occupancy grid in, says, I've seen some stuff, but basically it's keeping that little local map around it. And as it flies along, it basically just throws that map away. Now, we throw it away and put it in a big map, but we're not updating that big map in real time. This map is actually used for part of our planning. And what's described in the paper, if you take a look at it, is the way we're actually doing these calculations quickly is everything gets broken up into these polygons, and those are those green polygons those blue dots had to fit in, and that's sort of the way that we actually do the calculation really fast. So the result is we can do that pretty quickly, and we're actually able to fly that. So now we actually go into my lab, and the first set of experiments are just running through about half of the lab, sort of flying it up over stuff. And again, it's in these examples, it's the same as I described before. The vehicle knows where it is. We're using motion capture to navigate it, but it has no idea what else is in the room. So now it's just zooming back and forth in the room. And this is where it's using the sort of real sense, the vision system to look ahead as a point cloud, so it gets a sense of what's in front of it. It gets surprised by some stuff and then sort of goes around it. And it's particularly jumpy here because we've really tuned the attitude to high performance. So it's very sort of agile in its ability. So it'll do like Millennium Falcon type maneuvers if necessary to fly around things, okay? You get a sense of the velocity profile up here, which we're also optimizing as it needs to, okay? All right. So this is, path planning, and like I say, it's one of the things that is nice about this. And in fact, if you compare it against other algorithms, this is just a plot of sort of velocity versus distance. Not only are the paths we're creating shorter than other people's paths, we're actually flying faster along those paths than other people are as well. So it turns out to be a very effective technique. And so you get reductions of both flight time and also distance. And like I said, the hardware experiments actually got up to about 7.8 meters per second in unknown environments, which when you don't know what's in the room, is pretty fast to be flying. Because again, we can only see about 5 or 6 meters in front of us. And so it's pretty shocking when you see something at that speed. Okay. So changing gears a little bit, that's what we're doing in terms of flying when we have sort of limited perception capability.
Mundur sedikit. Siap. Oke, tadi dibahas tentang simulasinya dari hasil algoritma tadi di hutan gitu ya, kemudian di narrow environment ya, di office, dan ditunjukkan bahwa robot tersebut bisa sensing, bisa menggambarkan lingkungan sekitarnya dengan berbagai bentuk poligon gitu ya, dengan kesimpulan sebagai berikut. Mungkin mau ditanggapi terlebih dahulu, monggo Mas.
Ya, mungkin izin singkat saja, Mas. Ya, seperti yang disampaikan tadi, jadi nanti drone-nya akan buat mapping 3D, yaitu ada local map dan global map. Untuk yang local map-nya nanti digunakan untuk collision avoidance dan untuk pembuatan trajektori barunya. Kemudian untuk yang global map nanti digunakan untuk pathing secara globalnya dari source-nya ke goal-nya. Mungkin seperti itu, Mas Raymond.
Siap, Mas Raden. Terima kasih, Mas. Mungkin izin lanjut dulu ya.
Don't know what's in the room. It's pretty fast to be flying. Because again, we can only see about 5 or 6 meters in front of us. So it's pretty shocking when you see something at that speed. Okay. So changing gears a little bit, that's what we're doing in terms of flying when we have sort of limited perception capability for airplanes. This is the work we're doing when we have limited perception capability for ground robots. I mentioned this and we've sort of seen this video, but I'll play it here. It's sort of, so a lot of this work started off with the interest in being able to fly, or drive in this case, through environments with pedestrians. It's just sitting, getting prepared, ready to go. So we have a fairly high-level sort of planning scheme for avoiding the obstacles. What it's now focused on is the moving people. And again, part of the challenge here is being able to predict where these people are going to go, the extent to which they're going to cooperate with you or not. And so there's a very challenging planning or sort of aspect of the planning is that prediction and knowledge of sort of what else is going to happen in the world. And so In a lot of these cases, we have to make sort of educated guesses as to the extent to which these objects are going to be in the way at some point in the future. And the scalability of the algorithm in handling that type of prediction forwards can be quite complicated. So that's how Mike, the student working on this, sort of that was his master's thesis. One of the questions he then asked was, typically we're going to drop a robot off at the end of a driveway. We're doing a delivery. It might come off the car, it gets dropped off, and then you have comments like, go, deliver this package to the door, which makes perfect sense to a human. Doesn't make a whole lot of sense to a robot. It's missing basic things like, where's the door? What does the door look like? What is the map of this world? Now again, you could go through and map every environment you're going to go to, but the notion is this is any house in any neighborhood, and you just say, deliver this. So one of his questions he was looking at was there a mechanism by which he could use the knowledge that he is able to get from the robot to find a faster way to get to the door? So what he's taking advantage of here is the fact that we already know how to do a bunch of different things. And I think Luca Carlone is going to talk later, and he's an expert on things having to do with SLAM. So these techniques exist. We already know how to do planning algorithms over here, but one of the things we were missing was an ability to start mapping together the things that we do know, right? Like we're measuring things, we have a geometric understanding of the world, but we can also start developing a partial semantic map of the world. And by that, what I mean is things like, this is a stage, this is a floor, the door is over there. And so you can start labeling things at the semantic level. Then you can start understanding the relationships between semantic things, like if you're in an office, there tends to be tables and chairs. So if you see table and chairs, it's likely that you're in an office. And if you're in an office, it's also likely you might start seeing a printer. So you can start making semantic relationships like that at that level, which you can then use in the planning process. So what he's thinking about here is, for instance, can I start looking together things like driveways, sidewalks, hedges, bushes, and things like that as a connection mechanism to figure out where the door might be relative to where I am. But again, you're able to make connections that go way beyond the physical distance you can see because you can now start thinking about things at the semantic level. Now, anytime you have sort of one map that looks like this ends up being an image, which is sort of my semantic understanding of the world, at least at some partial level. What I want at the planner is something that's going to end up looking like a cost to go. If you've done things that look like receding horizon control, you need to have some sense of how do I get to where I'm going. He needs to connect these two things together, and that ends up being a giant mapping problem from one picture to another, and that's, of course, another deep learning problem. And so that's actually the technique he's been using to do that. He went through and hand-labeled a whole bunch of satellite images to get these semantic maps, then created the end result, masked them all up, and then did a giant learning problem to get a policy from this that actually enabled him to do that. The results are shown qualitatively here. And the fact that you can't tell the difference between these two columns is a good thing, because that actually means it's working extremely well. And this paper was also presented at IROS last week, so it's available on archive if you want to take a look at it. But the fact of the matter is that it's working extremely well for what it is we're asking it to do. And so if you compare that with, I don't know what this is skipping to, if you compare this with the standard thing you might expect to do, which is just exploration-based planning, where you're just saying, I'll just drop the robot off and let it explore, you can do that, but it's going to be super slow. And what he's looking at here is different types of environments and how his algorithm works compared to the exploration technique, and the result is pretty good. So he's been doing this in Unity, so we're doing sort of simulation-based training, but in the past week or so, he's actually been out in Michigan working on doing this on real robots, and I think, I'm not sure if we're actually going to have time to watch the whole movie, but basically what he's showing here in this picture is the process of I dropped it off, it saw the linkages, and what he ended up making up here is that partial semantic map, the estimated cost to go. He uses the cost to go to then educate his planner, and his planner then decides where to go. And so it's a little bit jerky, just because of the way the simulation runs, but this is sort of what you would expect the robot to be doing, hopefully a little bit smoother in the way that it actually moves. And so this is sort of what we hope to demonstrate in the next couple of weeks. And so Mike's actually beginning to think about future directions for his thesis work. One of the things that's come up is sort of anytime, again, you're doing deep learning, there's a question of, how.
Pause dulu, Mas. Ya. Oke, tadi kita ulas sejenak ya tentang planning beyond sensing horizon using learned context ya, dengan metode collision avoidance deep reinforcement learning atau RL tadi ya. Jadi berbagai simulasi dilakukan dengan algoritma yang sudah diterapkan gitu. Mungkin ada tanggapan terlebih dahulu, monggo. Mas Marwan atau Mas Maulana atau Pak Hari, silahkan.
Izin menanggapi Mas Raymond.
Siap, Mas Maul.
Yang kedua tadi yang robot beroda ya. Robot beroda ini dia kalau dilihat tadi kelihatannya menggunakan dua metode. Jadi ada odometri yang dia mengetahui posisinya dengan mengubah putaran roda menjadi jarak, dan dia juga menggunakan kamera ini 3D kamera. Jadi dia bisa mengetahui jarak objek yang di depannya itu berapa menggunakan kamera. Nah, tadi sebelumnya sudah disinggung ya, kalau challenge-nya robot yang seperti itu, kita harus bisa membedakan nih orang ini apakah akan memberikan jalan ke robot atau dia nggak mau ngalah gitu, dia jalan duluan. Nah, itu nanti diprediksi istilahnya trajektorinya orang tersebut mengarah kemana gitu. Jadi melalui trajektori tersebut bisa di learning untuk inputan ke robotnya, apakah dia berhenti atau jalan gitu. Ada go no go-nya gitu.
Siap. Siap, noted Mas Maul. Berarti tadi lebih ke ini ya, apa namanya, robot beroda tadi ya. Ini ahlinya robot beroda ini Mas Maul, ini udah sering juara. Mungkin next dulu ya, rekan-rekan.
Ya, punten Mas, apakah sudah bergabung lagi saya? Punten tadi disconnect sepertinya.
Oh, siap, sudah masuk Mas Raden. Mungkin kita next dulu ya, izin Pak Ari. Sekalian nanti yang video selanjutnya dulu. Monggo.
How is this going to work, or will it work? And so one of the questions here is a classic sort of issue in terms of anytime, like I say, you do neural nets, there's lots of examples that have been created where people put little things down and then convinces the algorithm to go and do stupid stuff like drive on the other side of the road and crash into people. And so the question that we had was whether or not it's possible to achieve some type of robustness in the deep neural net that we're actually developing, either for the type of work that Mike's doing for the delivery robots or just in general for the other kind of learning work. And so classically, the picture that we have is this, that basically we're a robot down here, the red guy, we're trying to get to our goal up here. So it's like a collision avoidance problem. There's just an adversary sitting in the middle here who not only can take an action to sort of defeat us, but actually can fool us ahead of time and deceive us by creating like an illusion of what it is that it's doing, which we then respond to as a red guy and then sort of try to go around him, and then the blue guy just sort of leaps over here and then ends up being in the wrong place. And the result is that we end up crashing into them. So what we have to do is what's captured in here, which is basically we need to come up with an action which is sort of essentially a measure over the set of actions we can take of the worst possible thing that can happen. And this is, if that's all, that's the problem statement, that doesn't really solve the problem. It just writes down what the problem is. It turns out if you take a standard sort of sampling-based strategy to figure out what is the worst case possible thing that could happen, this is very, very difficult to compute and very, very hard to do. The good news for us is that there's a bunch of people in the computer vision community been doing a similar type of adversarial problem, but they're worried about things like dogs and cats, not collision avoidance. It's like, can I show you a dog and convince you it's a cat? What we're interested in is whether or not I could have a blue agent or an adversary show me one thing and then fool me into doing a maneuver, which then I end up crashing. And they came up with a great way of actually doing a lower bound estimate of essentially what this thing is in this yellow box here, which is exactly what we need to know. And it's very fast, and we can actually run this in real time. And what we get out of this is not just a measure of this is what we recommend you do as a policy, right? Because we've designed a policy that's going to recommend you do something. We can actually analyze in real time how confident we are of the success of that. Like how safe do we think that policy is? And so we haven't necessarily sort of guaranteed it will be safe, but what we will tell you at execution time is whether or not we think it's safe. And so you can then use that to decide whether or not you're even going to execute it. And the result is, a picture somewhat like this. We're depending on how much robustness we embed into our uncertainty and what the adversary will do, we basically can dramatically lower the probability of collisions in this sort of simplified problem, the collision avoidance problem we've done. Okay? So that's pretty cool, because this is now taking applications or techniques that have previously only been used in very simple problems compared to what we're looking at here, and then advance them into a prediction over time of whether or not a collision might actually happen, which is a much more complicated problem than people had done before. And this paper was presented at Coral, which was 2 weeks ago, and this was the one that was in Japan. So that's, there's a paper online if you're interested in reading about that. Okay? All right. So the last piece of work then gets into some of the multi-robot stuff.
Mungkin.
And it's
Sebelumnya. Ya, mungkin bisa dikomentari dahulu. Mungkin izin Pak Hari tentang CARL ini ya, apa namanya? Certified Adversarial Robustness for Deep RL. Silakan, Pak.
Saya ambil sekilas saja karena ini butuh waktu panjang untuk menjelaskannya, tapi memang artinya reinforced learning ini menjadi hal yang penting dalam proses adaptasi. Jadi robot menghadapi situasi yang tidak pasti, kemudian dia berhadapan, dia harus mengambil tindakan apa untuk menghindari collision, seperti apa, langkah apa yang dilakukan, dan dia harus belajar dengan setiap situasi. Nah, proses reinforced learning tadi ini ya alhamdulillah juga bisa dibangun dengan sistem deep learning tadi. Jadi yang model neural network seperti itu, metodologinya sudah ada, dan alhamdulillah di posisi sekarang proses komputasinya lebih cepat. Sehingga proses pengambilan keputusan, proses untuk mampu beradaptasi terhadap setiap perubahan itu bisa dilakukan. Mesin akan selalu belajar dengan setiap kondisi tadi. Makanya modelnya reinforced learning tadi, dan itu certified, artinya bisa dibuktikan lah. Metodologi ini akan memungkinkan bila menghadapi situasi ini langkah apa yang harus dilakukan, harus menghindar, harus belok kemana, harus ini sudah dilakukan di proses yang dengan sangat cepat tadi. Mungkin sekilas ini kalau kita ingin perdalam. Makasih.
Siap, terima kasih Pak Hari. Mungkin izin next.
Was presented at Coral, which was 2 weeks ago, and this was the one that was in Japan. So that's there's a paper online if you're interested in reading about that. Okay.
Thanks.
All right. So the last piece of work then gets into some of the multi-robot stuff, and it's trying to develop what we call here a consistent multi-view problem. So a classic sort of scenario is I have a bunch of cameras that are all looking at this famous rabbit, and the question is, how do we actually align all these point clouds so that we can actually begin to fuse? So we need to agree we're all looking at A, the same rabbit, and B, what part of the rabbit we're looking at before we actually make this decision ahead of time. So that's sort of in a nutshell what we're trying to do. The sort of another way of thinking about this is that, you know, we go off and see the world and we come back and we're trying to align our different pictures of the things that the landmarks we might have seen. For instance, we might getting confused here about the Stata Center and whether or not it was a landmark, and whether or not it was actually connected to things like the Eiffel Tower and the Statue of Liberty. Okay. Now, again, classically here you'll see people doing pairwise type of alignment. I'll agree with you, you agree with someone else, and we'll just do all this in pairs. This is sort of the classic solution. What is completely missing, though, is the ability to use redundancy, because if we can all come to a consistent agreement on what's going on, now we have many, many people agreeing that redundancy, just like any other noise reduction problem, allows us to get some type of the sort of a noise reduction in sort of the actual sort of alignment aspect of the problem. So now in this context, what that ends up looking like is the word psychoconsistency. And in this picture, what it means is these green triangles. We basically want all of these things to agree that this is the Eiffel Tower. And once we've done that, now we can start reducing the amount of noise that's in this alignment problem that we actually have. Okay? Now, what you'd like to be able to do is to do this fast, and you'd like to be able to do it with high precision. And there's a bunch of techniques out there, some of which are the graph-based models, which are fast but not particularly high precision. The convex approaches or convex relaxations are high precision but not particularly fast. Spectral graph techniques are over here. Our technique actually shows up about here. Now, this is a cartoon, I'll admit. I'll show you some data in a second that actually sort of confirms that that's roughly where we end up. But we gain the benefits of a lot of the convex relaxation and spectral graph techniques. And we basically just combine the benefits of these two to get a much better technique. And this is actually just one data set we were looking at. This is our algorithm here, clear. And again, this is on the precision versus time plot. Basically, it's one over, it's sort of frequency. So you want to be over on this side. You want to be in the top corner. So it's similar to this graph here, the spectral methods on this plot, but if you actually skip to the next one that's looking at both precision and recall, the spectral technique actually got really good precision up here by having really crummy recall and is down here. And so our technique is the only one that's sitting up here. And so this is now allowing us to do consistent alignment between these groups of vehicles at a very high speed compared to some of the others. And so to give you a sense of that time scale, we've actually flown this on robots. This is actually flying around at NASA Langley. The picture here, and in fact, I don't think I fully appreciated why people keep getting lost in forests, is that trees turn out to be really useless landmarks. They're just big round things. They all look the same. And so for a robot flying around, it's very difficult to figure out how one tree differs from another. The point being that the geometric layout of these trees actually is the true signal we need to look at. Difficult for us to see, easy for
Next.
robots to see. What the perception thing, this is us. We have some red lines left, but basically there's just not a whole lot of data here. So we've made connections between things, and there's no real data suggesting we made any errors. They just don't have enough data. You can actually, they're just outliers. You can trim them out when you do that. In terms of some of the other, so I'll sort of stop there. Like I said, there's a ton of work we do in the group. Some of the videos.
Oke. Mohon maaf Bapak Ibu karena waktu yang sudah menunjukkan waktu sesi selanjutnya ya. Mungkin izin langsung diulas dari pendapat masing-masing narasumber aja terkait penelitian berikut gitu ya. Tadi yang terakhir adalah fusion representation kalau nggak salah ya. Penggabungan imaging dari penggambaran seperti bisa imaging kelinci, kemudian clear SEM, clear benchmark. Mungkin bisa disampaikan masing-masing insight-nya dari penelitian berikut. Terima kasih.
Saya dulu. Sekilas
silakan
ya.
Pak Ari dulu, monggo Pak.
Boleh. Jadi ini menarik tantangan-tantangan yang diberikan tentang kondisi yang tidak bisa diprediksikan ke depan, sistem robotik. Kita harus cepat mengambil keputusan, sistem komputasi yang efisien gitu kan, sangat cepat. Kemudian ada satu tambahan lagi yang menarik adalah ini gabungan tadi pas di ujung tadi kan confusion untuk menggabungkan semua informasi berkorelasi dengan jumlah robot yang banyak as a team. Masing-masing memiliki informasi, kemudian masing-masing informasi ini saling melengkapi untuk semua. Ini yang menarik. Jadi sebenarnya ketika jumlah robot yang dikendalikan banyak, maka satu ada kesulitan karena kompleks. Yang kedua, ini menjadi manfaat. Manfaatnya apa? Saling melengkapi informasi. Akhirnya peta yang masih buta tadi, masih belum jelas tadi, bisa saling dilengkapi oleh masing-masing robot yang mengalami pengalaman tadi. Itulah akhirnya semua informasi bisa terkumpul menjadi peta yang lengkap. Mungkin seperti itu. Manfaatnya akan ke depan akan lebih bagus lagi. Semakin jelas petanya, maka langkah berikutnya akan bisa diprediksi akan lebih baik. Kira-kira seperti itu sekilas, mudah-mudahan manfaatin nanti.
Siap, terima kasih banyak Pak Ari insight-nya. Mungkin dilanjutkan dulu Mas Raden dulu ya, silakan.
Ya, terima kasih Mas. Ya, untuk yang terkait dengan navigasi unknown environment ini, memang robotnya perlu melakukan mapping. Nah, dengan adanya lebih dari satu robot, proses mapping akan lebih cepat dan akurat. Contohnya, goalnya mungkin ada di dalam satu ruangan yang tertutup, kemudian pintunya satu saja. Kalau ada 4 robot, nanti dari sisi mana saja kita akan mengetahui mana pintu yang terbuka dan bisa lebih cepat untuk proses planningnya. Mungkin seperti itu yang dapat saya sampaikan. Terima kasih.
Siap, terima kasih banyak Mas Raden. Yang terakhir nih Mas Maul, silahkan Mas.
Ya, paling menambahkan dari yang sudah disampaikan oleh Pak Hari sama Mas Marwan tadi ya, Mas Raymond. Sudah disampaikan banyak hal, ini saya nanggapin dikit aja. Kalau yang dapat saya sampaikan ini sebenarnya sependapat sama yang Mas Marwan sama Pak Hari tadi. Jadi dengan menggunakan banyak robot, itu kan kita bisa membentuk representasi kolektif ya, karena itu robot lebih dari satu, kolektif dari environment dengan menggabungkan data-data dari banyak robot itu. Jadi waktu yang diperlukan juga lebih sedikit, dan hasilnya juga lebih cepat untuk melakukan mapping dari environment yang dituju. Jadi dia bisa membentuk representasi kolektifnya. Mungkin itu aja Mas Raymond.
Siap, well noted. Terima kasih banyak Pak Hari, Mas Raden, Mas Maul atas insight-nya. Jadi kalau bisa saya recap sejenak tadi ya, navigation dan mapping dari sebuah robot ini memerlukan perhitungan komputasional yang yang cepat gitu ya, perhitungan yang cepat, perkiraan yang cepat, sehingga robot-robot yang kita lihat bisa berterbangan, bisa bergerak secara otomatis itu memang perlu perhitungan yang certified gitu ya. Mungkin kurang lebih seperti itu. Masih ada waktu kah Mbak Natasha? Ini ada satu pertanyaan tadi ya dari Mbak Tanti gitu. Kalau masih ada waktu bisa saya sampaikan ke para expert ini. Ya, saya sampaikan ya pertanyaannya dari Mbak Tanti. Itu pertanyaannya untuk para expert nih. Ini kan expertnya robot ya. Digital talent seperti apakah yang dibutuhkan Indonesia untuk bisa memaksimalkan robotik? Ya, monggo bisa dijawab secara singkat saja. Silahkan. Mungkin dari Pak Hari dulu ya, yang sudah senior ini ya, sudah senior leader dari Telkom Group.
Bahasanya cukup tinggi, ya, alhamdulillah. Digital talentnya seperti apa? Oke, tantangannya adalah kemampuan matematis, membuat istilahnya algoritma yang rumit, gitu ya. Ini tantangannya menggabungkan semua informasi dan mengolahnya secara efisien. Jatuhnya akan lebih kepada bagaimana kita beradaptasi terhadap perkembangan teknologi. Teknologinya baik teknologi komputasi maupun teknologi implementasinya nanti, sistem sensornya seperti apa. Makasih. Sekilas
Siap.
gitu dulu.
Terima kasih Pak Hari. Bold notes-nya adalah beradaptasi itu tadi ya terhadap teknologi terbaru mungkin itu ya. Kalau dari Mas Raden sama Mas Maul, silahkan Mas. Ini yang Gen Y ya, ibaratnya yang anak muda zaman sekarang nih. Dari relate banget. Silahkan Mas.
Setuju.
Ya, mungkin kalau dari saya selain harus kuat di matematis, fisika, terkait algoritma juga, perlu kemampuan problem solving juga. Jadi seperti tadi contohnya terkait dengan limitasi dari sensor. Kalau kita hanya memakai satu sensor akan kesulitan, tapi kalau ada beberapa sensor akan mempermudah juga. Mungkin seperti itu, Mas Raymond.
Siap, mungkin yang terakhir Mas Mau, silahkan Mas.
Ya, izin Mas Raymond. Jadi tadi sudah disampaikan Pak Hari adaptasi ya. Kalau Mas Marwan problem solving, kalau menurut saya sih inovasi juga nggak kalah penting. Jadi dengan dengan menemukan akar masalah itu jadi bisa untuk mendapatkan sebuah inovasi baru gitu untuk pengembangan digital ke depannya.
Siap. Siap, terima kasih banyak insight-nya dari para narasumber, Pak Hari, Mas Raden, dan Mas Maul. Saya mewakili sesi pada pagi ini robotics ya. Izin undur diri. Terima kasih banyak. Mohon maaf apabila ada kesalahan, baik sengaja maupun ya tidak sengaja pastinya ya. Izin waktunya saya kembalikan kepada Mbak Natasha. Terima kasih banyak Pak Hari, Mas Raden, Mas Maul.
Terima kasih Mas Raymond yang telah memimpin sesi kita pada pagi hari ini dengan sangat menarik. Dan terima kasih juga kepada narasumber, yaitu Pak Hari Nugroho, Mas Raden Marwan Zanuar, dan Mas Maulana Valitur Rahman, yang sudah luar biasa dan telah berbagi sharing bersama kita, dan pastinya banyak insight yang kita dapatkan dan juga rekan-rekan. Semoga dapat bermanfaat dan dapat diimplementasikan oleh rekan-rekan sekalian semua. Selanjutnya, mari kita dengarkan bersama kata sambutan yang akan disampaikan oleh Senior General Manager Telkom Corporate University Center yang sekaligus akan menyapa rekan-rekan sekalian. Kepada Bapak Jamie Festius Confido, dipersilahkan.
Yeah, thank you, Natasha, for the introduction, and good morning, everyone. It's very nice to have all of you all together in this very interesting session that will be shared by MIT's expert. So thank you very much to Professor Michael Schartz and Professor Chuan Tang for the collaboration and the synergy between Telkom through the Indonesia Telecommunication and Digital Research Institute, or ITDRI, and MIT. And of course, thank you very much and warm welcome to all participants who are joining this session, both from your laptop or directly visiting the classroom. Today, we'll have a very interesting session regarding the innovation framework as well as transformation benchmarking from all legacy corporations, including who are in the telecommunication industries, as we know, as telco. And as part of one largest telco in Southeast Asia, Telkom is also in the middle of transformation process to become a digital telco. And we already have prepared and initiated a very strategic action, which we call the 5 bold moves, that will diffuse to all part of the Telkom group, including to the Telkom regional. And with the aspiration to become a digital telco, Telkom will play differently, will use different business model, will apply different operating model, and of course that will require different kind of skill set, including reskilling and upskilling from all Telkom employees. And as well, we will need to enhance our innovation capability as part of critical steps in the transformation process. So with this sharing session, we expect everyone will obtain inspiring insights from Professor Michael Schartz from MIT, and of course from sharing among other participants. And again, thank you very much to Professor Michael Schartz and MITs for sharing with us. And also thank you to all participants for joining this session. And we hope you enjoy the session very much, and we can learn a lot of insights from this session. Again, thank you very much and have a good day. Thank you. I return it to Natasha.
Terima kasih Bapak Jamie atas sambutannya. Baik, sebelum kita melanjutkan ke sesi webinar berikutnya, saya ingin mengingatkan kembali bahwa kami membuka pertanyaan di setiap sesi berlangsung. Jadi, silakan rekan-rekan menyampaikan komentar, pertanyaan, dan tanggapan Anda melalui chat box yang ada di sebelah kanan layar. Pertanyaan dapat disampaikan dengan format nama, institusi, tujuan narasumber, dan pertanyaan. Our college, we are moving on to the next agenda of the day. This second webinar session will be held in a hybrid from Telkom Korpu Area 2. Our topic in this webinar is how to be successful on digital experiments. In this session, we'll present our speaker, Mr. Michael Sherridge. Mr. Michael Sherridge is a research fellow with the MIT Sloan School of Management Initiative on Digital Economy. His research, writing, and advisory work focuses on the behavioral economics of models, prototypes, and metrics as strategic resources for managing innovation, risk, and opportunity. He's author of the award-winning book, The Innovator Hypothesis, Who do you want who do you want your customers to become? And Seriously Play. His latest book is Recommendation Engines, was published in September 2020 by MIT Press as part of its Essential Knowledge series. And for this session, please welcome our moderator, Mr. Hamza Asaduddin.
Ya baik, terima kasih. Selamat pagi. Pagi. Okay, thank you everyone for attending this session. We have a special guest speaker today. He is Michael Strage, and he is an MIT fellow. So he has an expertise within digital transformation, and he will speak more about digital transformation, especially for us telecoms company who want to transform, especially for telecom. In context to telecom, we want to transform to a digital telco company. Today, we have a mixed audience, Michael. So we have senior executives, also corporate entrepreneurs from various backgrounds, from corporate university or from digital business. We also have our honorable guests from our partners as ITDRI. Kepada Bapak Ibu sekalian, kami ucapkan terima kasih atas kehadirannya pada pagi hari ini. Okay, so without further ado, let's hear from Michael, please.
Good morning. And if we could just switch the last thing I want to see is me. I would rather see the slide. So it is both a great pleasure and an honor to have this opportunity to talk with you and to listen to you on these fundamental critical issues of digital transformation. All telecom companies have, of course, become more digital, and indeed the challenge for legacy telecom companies like Indonesia Telecom are particularly difficult. I have had, through MIT and the Industrial Liaison Program, the opportunity to work with legacy firms such as BT, British Telecom, Verizon, AT&T on these kinds of issues. We are not going to talk about LTE or 5G. Instead, we are going to focus on fundamental principles of digital transformation that reflect research that I've been involved with at MIT over the past decade. Much of this research I have translated into executive education programs, not unlike your Indonesia Telecom University, that I believe will be both relevant for you and actionable. When I was introduced, there was the discussion of insights. I hope that you will find much of what I have to say to be insightful, but I also want you to find it useful and usable. I know that internal entrepreneurs, particularly with digital services and a B2B focus, are represented here. I will be shocked and disappointed if you do not find my comments directly relevant to your next 30, 60, 90, 180-day benchmarks. I assure you, you will have the opportunity to give me feedback on this. So, my talk overview is essential principles and practices for digital platform design. Of course, it will also apply to services and digital products. And I want to talk particularly about what works and why for telecom. What is the one big advantage legacy telecom companies have about digital? It is you have always been in a network business. You have always been in a network business. Now, there are differences between TCP/IP protocol and 5G networks and analog networks, but there is something in the DNA and the culture of telecoms about networks, and to the extent you can leverage, build on that insight, that capability, that perspective on networks, you will have a competitive advantage. My talk that I'm giving is going to be based on some of the publications that I've done from Harvard and MIT and Sloan Management Review. For those of you who are going on a long trip or who have difficulty sleeping, I urge you to look at some of the materials here. This is my most important slide. The content of the audience is more important than the content of the talk. I know my material very well. I will not be modest. I have an excellent command of my subject. That is why I am here. That is why I flew all the way to be here. That is why I am representing MIT. But that is not enough. MIT is a university. This is a university. It is important that my material, my content, my insights create a feedback loop with you. So it is important, if there are things that I say that require clarification, amplification, or disagreement, please let Hamza know, remotely or here. I am happy and quite comfortable being interrupted by students, colleagues. I am pretty sure I will be able to deal with any questions or concerns that you may have. I have discussed these kinds of digital transformation issues with these kinds of companies worldwide. I have worked with all of these organizations, and I hope that they would say that they've learned as much from me as I have learned from them. I am hoping to learn from you as well. We're going to be talking about digital transformation. I think it is essential to define one's terms on this, because I do not like it, and I know I am speaking English, and this has to be translated, and that makes definitions and specificity that much more important. I focus around transformation, not how do we take everything that we do well and make it digital? No. In America, in English, we call that lift and shift. I am not a lift and shift kind of guy. My view is the lens through which you should be viewing your digital transformation is what kind of capabilities do digital transformation permit? What kind of new powers, what kind of new abilities does moving from your legacy networks to digital networks permit, encourage, enable? Capabilities are key here. I do not know how that translates into Indonesian, but when we talk about this, that's what I want to focus on. Not just what is the task you wish to accomplish, but the capability your investment in digital enables you to create. Let me tell you a quick, true story. I will not give you the name of the legacy company, but it is a company that everybody in this room knows, a global company. Over about a decade ago, it's 2022 now, about a decade ago, I was working with them. And they were very interested, they were big in mobile, etc. And they had set up a data science, marketing science, and analytics group. And they had asked their analytics group to come up with, I know this isn't B2B, although it is relevant in B2B, they had asked them to come up with a churn prediction model. Right? People here understand churn. Yes? Okay. Big deal. So, the data science people had come up with a very, very good churn prediction model. Guess what they discovered when they applied it? I do not think it will surprise anybody in this room. When this giant company looked at the churn prediction model, what were they most effective at predicting? The customers chasing after the cheapest rates. Right, that is the laughter of recognition there. It was not useful at all. Those are the kinds of customers they didn't even want. So the real question was not, how do we build a better churn prediction model? It was, how do we value customers that we want to keep? This insight, and I will immodestly say I was a part of the group, made the organization realize it is more important to begin analyzing customer lifetime value than churn prediction. Now, this is a huge legacy company. Where do you think the data for calculating recency, frequency, monetary value, where do you think the data for calculating customer lifetime value was? Like you, all over the place. There was no repository, there was no central data there. This insight, though, forced them to realize we need to do a better job of metadata, tagging our data, and creating a capability around building customer profiles that allow us to do customer lifetime value calculation. Digitalization leading to a new capability measured by a new KPI, key performance indicator, customer lifetime value. Let me be very rude and ask, how good is Telekom Indonesia at calculating customer or client lifetime value for B2B clients and consumer clients? Good? All very good? So, first insight. This is what a legacy company did. Now let me ask one last unfair question. Is there a data governance group? Is there a metadata or labeling group, a marketing group that allows us to put together, to join databases that give us insight into recency, frequency, renewal, monetization for calculating customer lifetime value? Is there a team, is there a small entrepreneurial team doing this right now? Does anybody own customer lifetime value, client lifetime value? It's okay that you don't have to give me an answer right now, okay? You can tell that I teach in exec ed on this, I'm sorry. But if there is just one takeaway that you can have from this, it's how can you go wrong if you are having a conversation about calculating customer lifetime value and sharing data that gives you insight into customer lifetime value. And we know that this is as true for B2B, software as a service, subscription services, as it is for family plans. Okay? Very long, short story, but it illustrates a fundamental principle about how digital can create capabilities for new ways of doing value creation. And these are the three, forgive me, my surname is Schrage auf Deutsch, so I'm going to talk about the digital Schwerpunkt. Schwerpunkt is a German word meaning for the tough point, the center of gravity. Every single organization that I've worked with in executive ed or in an advisory role, these are the three organizing principles that I insist the legacy organization deals with. The first is, what are the capabilities? How do we define capabilities? The second is, and this is absolutely key for the small B2B teams represented here, not what is the digital service we want to provide, not what is the digital product we want to provide, not what is the digital platform we are building. The question is, what are the use cases those services, those products, and those platforms support? That is one of the fundamental changes. My husband is a mechanical engineer. When I was in school studying computer science, which believe it or not was a long, long time ago, we did what? Requirements and specifications. The design revolution that has occurred is not how do we do a better job of gathering requirements and specifications. It's how do we do a better job of articulating and defining the use cases the software, product, or service enables. And the final organizing principle, we talked about use cases, value, because I like measurement, value realized from UCX. What is UCX? The use case experience. Notice that I'm not saying the customer experience. Notice that I'm not saying the client experience. Because the use case can be an internal use case for technical support or the developers, or it can be a use case for the channel partner, as those represented in this room, or a customer or a client. So it's not just having a good use case experience. What is the value realized from this? These are my 3 key points. This talk, and we can stop the talk after this right over here, because I can tell you're getting tired already. This talk is about digitally transforming customers. That is the end. That is the goal. How does Telekom Indonesia want its digital offerings to transform its customer capabilities, its customer values in the B2B space, in the individual space? I read your description online. You are talking about becoming a customer-centric organization. Customer-centric doesn't just mean giving customers what they want. It means empowering them and transforming them. I will go into detail on that shortly. The second organizing principle, and this leverages your network legacy and what digital transformation can and should and does mean for successful companies. Dare I say it, companies like Gojek have done. How do you design data-driven virtuous cycles? The end is transforming customers. The means is designing virtuous cycles, digital data-driven virtuous cycles. And the third, you'll forgive the mild, and I'm sure there are enough technical people represented here, yes? People here know what APIs are, yes? Okay, here is my motto for you. How do you align APIs with KPIs? What are the ways you architect data flows and workflows to the key performance indicators, to the measures that matter most? Whether those measures be churn, whether those measures be net promoter score, whether those measures be customer lifetime value, whether it be effective network utilization, reduction of downtime, etc. These are my 3 organizing principles. That is what I strongly, every single team represented here should be able to have an answer to this. They should be able to answer how we want to transform our customers. They should say, here is the virtuous cycle we're enabling to do so, and here are the ways we're aligning our APIs with our KPIs to have architecture deliver the outcome that we want. That's it. Can we stop the talk now or no? Should I go on? This is my most important call to action. How should Telekom Indonesia, I apologize for the misspelling, I just went with the English spelling. How do you make your customers and clients more valuable? Not how do you make yourselves more valuable, how does your digital transformation make your users more valuable and more capable? My digital transformation principle is transforming customer value matters as much as improving organizational and operational efficiencies. You have to do both. If you are just focusing on internal efficiencies, you are digitizing for yourself. If you just focus on adding customer value, you are creating inefficiencies and gaps that remove your ability to be agile, responsive, anticipatory. We're back to the alignment issue. How do we align organizational and operational efficiency with the customer value creation that we care about? My argument is this. How do we measurably transform value-creating customer capabilities through data-driven virtuous cycles? This is the advice. This is the heuristic. This is the guiding rule and principle I share with all of my executive ed classes. For all intents and purposes, I've turned you into an executive ed class. Most of my classes go fairly well. I hope this one does also. This is where every serious digital transformation organization ends up. This is going to be one of those areas where if you disagree with me on this, you are wrong. I am sorry. This is the digital transformation destination. We have the KPI, the thing that it matters to us, the measurement that matters to us. Revenue, profit, EBITDA, utilization. We have the data governance, data quality, data governance. And we have decision rights. Who gets to make the decision about what to do? With an algorithm, we may automate the decision rights. We can do this with CLV. But notice what we have here. We have a cycle. We have a loop. I have a key performance indicator. Let's call it customer lifetime value. We get more data. Gee, we get more data. How does that change how we should make decisions around improving or managing customer lifetime value? We're automating certain things. What kind of data do we need to make sure those automations are accurate? What impact will it have on the key performance indicator? What is the sin? What is the flaw? What is the horrible thing about legacy companies that get in the way of this? I will tell you because you already know. You have silos. You're vertical. Every 3 or 4 months, you get together and decide what's the good indicator. Every 3 or 4 months, you decide, oh, what's the new data that we can add? Every 6 months, you send people to Telkom Indonesia University and make a decision about, do we automate this? Do we have a small team decide? And then you go away and you come together. What's the digital loop here? The key is creating links between these two, not having meetings 3 or 4 times a year on this. Digital transformation means creating a network between key performance indicators, data sets, and decision. In other words, how do we create a virtuous cycle between better data, better decision, and better performance? That's it. If you cannot demonstrate in your startup, in your entrepreneurial effort, if you cannot demonstrate in your product, service, or experience this kind of a loop, you may be good at what you do, but it is not a digital transformation. Digital transformation means you have this kind of virtuous cycle. Your challenge in digital transformation is how do we digitally align virtuous cycles, KPIs, and customer transformation. That is your architectural challenge. That is your architectural opportunity. I focused on this in my book. It's literally a decade old now. Who do you want your customers to become? Okay? Bear with me for a couple of minutes. I want you to think about your best customers and your typical customers. And I want you thinking about this question as I talk for the next 3 minutes. If these customers stick with you for 2 years, 3 years, as you digitally transform, how do you transform your best customers, and your digital customers, your typical customers? We have a little too much feedback in here. That's the question I'd like you to consider. Okay? So let's go back. The classic marketing question, and I'm saying this to you because you say on your website that you're a customer-centric organization. The classical question, marketing question, was raised in 1960 by Ted Levitt in his article, Marketing Myopia. This is the most popular reprint in the history of Harvard Business Review. And the fundamental question that Ted asked, he was a very nice man, was What business are we in? What business are we in? Are railroads in the railroad business, the transportation business, the logistics business? Are oil companies in the oil business, the petroleum business, the energy business, the hydrocarbons business, the chemicals business? What business are you really in? Okay? Completely logical question. It's one of these things that the more people thought about, oh, wow. And because of what? Technological innovation and globalization, organizations need to constantly revisit, what business are we in? Now, let me tell you a true story. I read this article, and Ted Levitt was talking about, well, there's this thing coming in from the people, even in Indonesia, horses and carriages. And there's this thing called the horseless carriage, the automobile. And what business are the buggy whip manufacturers in? Are the buggy whip manufacturers in the fine leather goods business? Are they in the animal control business? Are they in the steering business? And do you know what answer Ted Levitt gave? He didn't. He didn't answer the question. And that bugged me. That bugged me. Okay? I like Ted Levitt's question. But for too many organizations, they look at digital innovation and digital architecture as, how can digital innovation better define and support the business that we're in? What business is Telekom Indonesia in? The telecommunications business. Here's my suggestion. That question is a good question, but it's not enough. I want you to change the focus. So let me ask you a question. Everybody in this room knows Henry Ford. Everybody in this room knows the Model T. What was Henry Ford's real innovation? Most important innovation? Change the color? No, every color you want except black. I know that joke, yes. Okay. That's the famous story, yes. And the reason why is because black paint dried the fastest. Just so you know. It's not because that was his favorite color. That's the most efficient one. But what do you think his most important innovation was? Engine? The mass production, right? Some people say River Rouge, vertical integration. Sorry? Understand the customer. Close, but he was really a mass production guy. That's what Fordism was. This is all correct. I think these are completely reasonable things. By the way, one of the reasons why my colleague and I were late getting here was because of the traffic. So I think you will appreciate what I'm about to say. I am here to tell you, remember, my background is economics as well as computer science, that as important as mass production, cheap mass production, vertical integration, efficient painting is, the most important innovation of Henry Ford is the driver, the human capital of driving. Where on the balance sheets does it show the value of the human capital of driving? How many of you drive? Okay, where in the Indonesia GDP is that capability? It's not there. Shame on the economics profession. But I will argue, and I hope you will agree, that creating millions of drivers is a pretty important innovation. That's a global phenomenon. Now, we can talk about autonomous vehicles, but that's not the point. The point is the fundamental innovation transformed human capital. Everybody here knows Google. I could take Baidu as well. I could take Alibaba. It doesn't matter. But you know how Google works, the Google algorithm works. Who does Google want its customers to become? Searchers, page rank searchers. What the key, if you don't know the key to how the page rank algorithm works, it's remarkable. They scrape the links that other people use. What Google does is it converts its users, the human capital of its users, to make a more accurate search. whether for Google Maps or anything else. Okay? Everybody works for Google and they like it. And Google has figured out advertising to monetize this. But again, Ford, human capital, Google, human capital, technology that transforms the human capital and capability of its users. Who does Netflix want its customers to become? Binge watchers, people who will watch TV, this shows for hours at a time. I love this. So this is from a restaurateur, Danny Meyer. I did some work with a company, you know, Booking.com. Booking.com bought Open Table, a reservation system, and Danny was the speaker there. And I love this quote. He said, "I used to be annoyed when diners would take pictures of their food. Now I'm annoyed if they do not." Okay? Completely different. Notice what's going on here. A fundamental change in behavior enabled by technology. I know you're concerned about B2B. B2B networkers. Who does GitHub want its customers to become? People who set up repositories and frameworks and exchange on this. All of these entrepreneurs could answer the question, the Ted Levitt question, what business are they in? They could also give the vision into who they wanted their customers to become. The challenge for the people in this room, particularly those entrepreneurial units, is how do you align the answers between what business are we in and who do we want our customers to become? Digital transformation is an investment that reduces the coordination and transaction costs of enabling alignment between the answers to those questions. What business are we in, and who do we want our customers to become? My argument to you is that you should not just look at your innovations as faster, better, cheaper products and services that solve a customer problem, but as use cases that are investments in the human capital, capabilities, creativity, and competences of customers and clients. Digital innovation is an investment in your customer's capability, your customer's future, your customer's transformation. Back a couple of 100 years ago, when the mining industries ruled Europe, Monsieur Leplay, Frederick Leplay, was the first, an industrial sociologist, was one of the first superintendents of the École des Mines, the School of Mines. And he said the most important product of the mines is? No, not the coal. The miner. Not the coal, not the tin. I know there's mining in Indonesia. It's the miner. It's the human capital. And that is the key message I'm trying to share with you about your importance of digital transformation. And it's key, that's why things like this university is so important, because it's a recognition that investing in your human capital may improve the ability, your ability to add value to your customers' human capital. My argument is, can I borrow your mobile phone for 1 second? Yeah. Thank you. I promise not to do anything bad to it. So, the most important product of the mine is the miner. The most important product of the network is the networker, not the bits, not the bytes, not the bandwidth. It's the apps. It's the connections. That's the key. That is the business that you are in. You are transforming not just the network, but the networkers. That's what your devices enable. That is what when people connect to you, that is what you should be facilitating. So, my argument is virtuous cycle. We shape our innovations, and afterwards our innovations shape us. Oh, look. Oh, look, another virtuous cycle. Do people here think that Amazon is a good example of digital transformation? I do. I have worked with them. They're very good at what they do. These are smart people. Okay, don't forget, they took their retail infrastructure and turned it into Elastic Cloud and AWS. Pretty bloody impressive. But look at what they're thinking in terms of. Okay? Virtuous cycles. Facebook, same thing. Virtuous cycle. Uber. I'm sorry I didn't do Gojek, but you get the same point. Virtuous cycle. Even in bed, Netflix. This is an engineer, director of engineering. Virtuous cycle. I go all over Telekom Indonesia website. What do I not see? Virtuous cycle. Where are your Starbucks rewards here? Data network effects. Where are your virtuous cycles? Are your small entrepreneurial teams thinking in terms of virtuous cycles? Let's stop for a moment. Any questions, any comments? Do people here understand there's a difference between optimizing a process and creating a virtuous cycle? Because Amazon, Facebook, and Uber, and Gojek certainly understand the difference between process optimization and virtuous cycle. Questions? Does anybody have any questions, comments?
Jika Bapak Ibu ada pertanyaan, bisa langsung diajukan atau bisa lewat saya juga bisa gitu. Teman-teman boleh nanya bahasa Indonesia, nanti kami bantu untuk translate. Okay, so Mr. Suranta.
Sure. Yes. Yes. I understand that. Yes, I understand and agree. And now, forgive me, but this is the advantage of being an American coming in from overseas. I get to be rude and leave the country on this. I have given you the answer to that question. It is not, do we begin with 100,000 employees and upskill them? Do we begin with 200 million customers and give them DIY or give them tool? No, here's the discipline. What are the use cases that matter the most? What are the use cases? Is it allowing people to log on and do a mobile transaction? What are the use cases that you want to enable? And then you decide what are the high value, first off, you're a regulated company. What are the use cases we have to do to comply with regulation? I accept that, okay? That is true all over the world. Then it's, what are the high value added use cases? Is it in mobile payments? Is it in retail? Is it in QR code conversion? I have no idea. I'm not here to tell you what your most important use cases are. Here's what I'm here to tell you. If you do not have a list of your 100 most important use cases with business value attached and teams supporting that attached, then this is a silly conversation. Okay, it is not, and let me be completely clear here. It is not unfair for your board of directors or for your biggest corporate clients to say, here are the use cases I want you to support in our dealing. I know that one of your 5 pillars is B2B, networking, EDI, electronic data interchange. That's a use case. Can I do supply chain management? Can I consummate a transaction? Is it transparent? So, question, are the APIs internal or are they exposed? Those are the kind of questions you have to deal with. But what does it begin with? It does not begin with the customer. It does not begin with your employees. It begins with a use case that does or does not add meaningful value to a customer or is regulatorily necessary on this. Okay? Sure.
Regarding the use case that you mentioned, that's identical with the core process, right? Yeah.
Not quite. Core processes
Correct.
should support use cases.
Yeah.
And this is key. If the core process is disconnected to a use case or is only done to convert to cash, what you have is a financial process, not a telecom process or a use case experience process.
Yeah. So my question is really, how do you define the priority use case in the
I will give you
is
a very
there
good answer. If you give me a lot of money, I am happy to sit down with you and define your use cases. But if I were you, the people represented in this room, I would say, who are our, well, I know this is being recorded and streamed, but give me an example of a big customer that you have that you care about. It can be a bank, it can be a retailer. Who do you care about? Give me a big customer you care about. Give me the name, which bank? BRI? BRI, okay. So let's sit down with BRI and you say to BRI, in 2023, what are the 3 most important digital-based use cases you are going to offer to your customers or use to manage your processes? And then you take their definition of a use case and do what? Map it to yours. Okay? Or you use their use case as an organizing principle to do what? To align data flow, workflow to API to KPI. What's the KPI for that BRI use case? I don't know. But you better be able to support the APIs that lead to that KPI. That's what digital transformation means, or they will go to another network. Okay?
So I have another question from the audience.
Of course.
When we talk about digital transformation, we have like a lot of heads, right, in the organization.
Yeah.
So how should we define one for our organization, and who should we follow? I mean, if you talk to different people.
I'm sorry, define head of what?
Yeah,
for the organization?
so if we talk to different people within the organization, they're going to have different meanings of digital transformation. Yeah.
So if one works with I will not speak inappropriately or out of school. I have done work with Amazon. Very interesting company. There is a simple way that Amazon, they don't solve the problem. What you've identified is a huge issue. But this is the way they manage the problem. Traditionally, large organizations look at their assets and say, how do we organize and ensemble our assets efficiently so we can go to market? Amazon does not do that. Amazon designs from the outside in. They begin with, what is the customer experience we wish to create? And that, the way the customer experience is defined, determines the way internal assets are ensembled, coordinated, and managed. So this is a very big cultural challenge to go from inside out to outside in. But you will note, Amazon is in your business. AWS. Google is in your business. Okay? You know, these companies are moving. Ali Cloud. They're in your business. Okay? Last question, and then we'll go on.
Okay, so there's another question.
Yeah, okay.
So within our organization, we have entrepreneurs.
Yeah.
And mostly entrepreneurs are people who go out of their comfort zones.
Yes.
So how would you recommend Telkom to motivate and make sure they do go out of their comfort zone to help the business transform?
So, I apologize. You know, honestly, I don't care whether you're in your comfort zone or not. Are you creating value for your customers and with each other or not? Some people are very comfortable listening to customers and turning customer stories into use cases, and they're not uncomfortable at all. Some people are very uncomfortable taking technology they know and putting it in front of somebody. I don't think the issue is getting out of your comfort zone. I think the issue is creating a virtuous cycle of what do universities facilitate? Learning. Here's my advice. If learning makes you uncomfortable, you are in the wrong business at the wrong time. The issue that you have is not, how do I get people to buy my product? It's, how do I learn from the people I'm working with and for to use technology to meet the needs and the value as defined by the use case, the capabilities, and the value from the use case experience. So if you are uncomfortable, it is like exercising. Sometimes you can get where you want to go without feeling uncomfortable. Other times, every step is painful. The issue is, are you getting there? Are you getting there? Are you making progress? My view is, Telecom Indonesia is making investments in people, like relationships with MIT, to build those capabilities. Okay? And this is, I'm defining virtuous cycle here. This is the KPI I want to see in Telecom Indonesia this time next year. What is your return on virtuous cycle? The challenge I have for every single B2B entrepreneurial group here is the product that you're working on, the experience that you're working on, the service that you're working on, can it be turned into, or is it already a virtuous cycle that enables learning and improvement in the same way that Facebook and Starbucks and Google have that? My view of platforms is that they enable virtuous cycles. The best definition, and by the way, I think virtuous cycles means network effects. What did I say legacy telecom companies understand? Networks. Now I am asking you to understand network effects. My colleague from MIT, he's now at Boston University, his name is Marshall Van Alstyne. Doesn't that sound like a villain in the Marvel comic? But he's a wonderful guy, good collaborator. His simple definition is users creating value for other users. Okay? Not suppliers creating value for customers. It's not a linear thing. It's users creating value for other users. I urge you to look at your network assets and ask yourselves, how does Telecom Indonesia's network allow or make it easy for users to create value for other users? How are you facilitating and enabling network effects? My spin on this, because I talked about the importance of data, is users creating valuable data for other users. You know this guy. He used to be popular in China, no longer, but we're not here to talk about politics. I had the opportunity to work with him at Microsoft. Very sharp guy. I don't need to read all of this to you, but you will immediately get the point. We're not a gross merchandise value company, but a data company. We sell stuff to collect data. Let me give you a $1 billion suggestion for free. For free, okay? We sell stuff to collect data. You provision networks to collect data. Who owns metadata at Telecom Indonesia? My bet is no one owns telecom, maybe compliance. Who owns metadata? Does anybody own metadata? Do you have a metadata roadmap? Okay, not yet. Now, didn't this good, not yet is a better answer. Didn't this gentleman just tell me a few moments ago that you have at least 200 million customers? That's a lot of customers. Even if only 10% of them are generating valuable data. So, do you have a plan to monetize that? The answer is, not yet. But these are not, again, these are not trick questions. These are not unfair comments. By the way, what company does a wonderful job of doing this? Alibaba, Alipay. They did such a good job that Jack Ma is no longer there. But again, no politics. Okay? Data is an asset. I know this is not a surprise to you, but is data being managed as an asset? How are we doing on time, by the way? I'll go for 5 more minutes, then we'll do Q&A, okay? I haven't gone through even a fraction of my material, but too bad. Is data an asset at Telekom Indonesia? So I think it is very dangerous. I love your answer, I love your honesty, but it is very dangerous to have the motto of Telekom Indonesia be, Telekom Indonesia. Not yet. Okay? Here is the homework for you. Okay? What are Telekom Indonesia's most valuable data sets? Why? Do you know where the most valuable data sets are? And what use cases they map to? Not yet. What one thing would make that data more valuable? Would it be better analytics, or would it be connecting it to other data sets? But how would you know? And because I care about privacy and safety and assurance and regulation, what one thing would make that data safer? And would your CISO agree? Every single manager at Telekom Indonesia should have an answer to these questions. Every single one. And we should create a database for it that's searchable. Everybody should know what the most valuable databases are. There should be metadata about valuable databases. How can we make sharing that data faster, simpler, and easier? We're back to virtuous cycles. Are you creating deliberately, not by accident, are you creating a virtuous cycle of data? This is why, back to the original thing, data governance is so important. Do you have a data governance roadmap? Please don't say no. Yes, good, there we go, okay. Yes, okay. Very good. May I ask a slightly unfair question? How old is that data governance? I don't know, okay. Excellent. What is the biggest progress that's been made in 5 years? Excellent. Relational databases or non-relational databases? Good. Okay, so there is progress on this. Are you mapping use cases to databases? Excellent. Then there is. That's right. That's fine. But excellent. So let me ask one last trick question, then we'll do 2 more, and then we'll open it up to questions. Do you have a database of use cases? Of use cases. Do you have a repository, a repo of use cases? You're nodding? Fantastic. Separate. So we need to figure out metadata for use cases so people can share and see frameworks. By the way, that's what GitHub and GitLab do, right? For frameworks. So there are models, there are templates for this that are not too expensive. But thank you for that update. I'll go for 2 more minutes. Okay, so this is the other KPI. What is your return on data? And we're talking about interoperability. I'll be very quick here. We talk about APIs. Do you know, I'll stop on this. Have you heard of the Steve Yegi memo from a decade ago? So I urge you, I'll share the slides. I urge you to look at this because it is more on point now than it was when he wrote it. Let me give you a quick bit of the background. This was a developer who went from Google to Amazon, and he realized that Amazon managed these issues completely differently than Google. And Google, they're not stupid people at Google, okay? My brother worked at Google, you know. My brother went from Google to Facebook. When my brother went from Google to Facebook, he raised the IQ of both companies. I say that because he went to Harvard. Look at this. All teams will expose their data and functionality through service interfaces. Do your teams expose data and functionality through interfaces? No? Okay, this is what made Amazon Amazon. Okay? This is not hypothetical. This is from a decade ago. Amazon won. They beat Google in the cloud on this. Teams must communicate each other through these interfaces. There will be no other form of inter-process communication. Doesn't matter what technology. All service interfaces must be designed from the ground up to be externalizable. That ties into your use case question and customer question, okay? And now, just to make it a real thing, this was the important cultural innovation. If you didn't do this, what would happen? You would be fired. That's leadership. That's leadership right there. We'll do the last one here. This is where I'm going to end, particularly for the B2B business teams. I'm talking virtuous cycle, virtuous cycle, virtuous cycle. I'm talking interoperability. For all of your B2B entrepreneur teams, this is the virtuous cycle you want to create. I'm creating an app that creates a capability or functionality, right? What are the analytics about how well that app does or does not work? Okay? Gee, if I externalize it with an API, how can I add value to it? Or I have different analytics. How do I need to change the app? Do I need an API to do that? I have analytics that make a suggestion. Do I create an API to create interoperability? Do I create an app? I have analytics that suggest an app. How do I create an API? Virtuous cycle, virtuous cycle, virtuous cycle. Not process optimization. How am I using digital architectures to facilitate and enable virtuous cycles? That is what digital transformation can and should mean. And at places like Amazon and Google and Gojek and Microsoft, that's what it does mean. I advise that it also come to mean that at Telekom Indonesia. I'm happy to answer any questions, and then you won't have to see me again.
Ya, terima kasih Bapak Ibu sekalian. Apakah ada pertanyaan yang mau ditanyakan? Kita buka dulu yang 3 pertanyaan. Mas Randa, silakan.
I want a question from the not yet gentleman. Okay, sorry.
Pakai bahasa Indonesia boleh ya? Di sini kan kita ada beberapa teman-teman yang memang dikejar revenue tuh, Mas Hamzah, gitu ya. Teori customer oriented itu udah paham betul lah, gitu ya. Tapi kadang-kadang karena kita memang dikejar KPI-nya adalah revenue, gitu ya. Kadang-kadang untuk spare time untuk thinking about customer tuh kita nggak ada, gitu. Jadi kira-kira pendapatnya gimana, gitu ya? Gitu.
Okay, thank you. So we have a question. So from the entrepreneurs, they already understand about customer orientation in theory.
Excellent.
In theory, but they are being driven by the KPI, so they have to achieve their KPI, right?
My sympathies. I understand. Okay.
Yeah. So they don't have any spare time to think about customer orientation.
Well, now let's play. Tell me what the product or service that you're doing. Tell me about the KPI, and we will figure something out here. I do this for a living. So my serious research is on the future of KPIs. So I think I may be able to be of use. Tell me the product, tell me the KPI.
Okay. Ada yang mau duluan?
Saya serahkan Mas Rizky. Taking for example ya, omnichannel assistance. Yeah.
Love it, omnichannel.
Yes, yeah. So we are sending. Oh, kok jadi bahasa Inggris ya? Bahasa Indonesia ya. It's okay.
English, if you have, go with English and switch whenever you're comfortable. It's fine with me.
So basically, the product is how we can go to the customer using WhatsApp Blast or something like that. CRM, right? CRM, Customer Relationship Management.
Okay.
Okay.
It's a CRM.
Yes,
it's a customer
yeah.
relationships management system.
Yes.
It's for omni-channel.
Omni-channel.
So, right. Very good. Okay.
And the main revenue is the revenue. Yeah. So every quarter will be the management will how percentage you achieve of the revenue and something like that. The KPI is revenue. On the revenue, right? Yes, mostly revenue.
So I will offer, so I will tell you a true story completely related to this. It is, forgive me, it is a bit of a trick, but I think it is a trick your bosses will take seriously, okay? Everybody in this room, I used to do work in the Philippines. Everybody in this room understands call centers and contact centers. Everybody is concerned with efficiency in contact centers. Remember, 10, 12 years ago, what was the measure of productivity and efficiency? Number of calls processed per unit time. And then, when they did a survey, what did they discover? People were being more productive, but the NPS, the Net Promoter Score, the customer experience score was 0. 0. So they became, if you will forgive my English, counterproductive. Here is my suggestion. You say, we want revenue. Of course we want revenue. But we need to make sure that we do not get revenue at the expense of customer experience. Allow us to do NPS or some sort or customer effort score so that we have a balancing act there. Because you are correct. If it's just revenue, you will cut and cut or sell, and it will have nothing to do with the quality of customer experience because revenue is a bad proxy for customer experience. So the question then becomes, how do we get leadership? And we're now back to the very beginning question. Said, if we care not just about revenue, but customer lifetime value, revenue over time, you will need to do historical analysis. When people use your CRM, when do they abandon it? When do they stop using it? When do they ask for additional features? But the point is, you need to have a data-driven story that segments your customers. Who is the best customer? What is the name of your product? Omnichannel?
OCA.
Who are the best OCA customers? Who are the typical customers? Here is the way we want to grow our best customers. Here's the way we want to upsell or upgrade our typical customers. So you are correct. You are trapped if the only or dominant metric is revenue. You will have a chance if you create KPI twin that respects the customer. And you should be able to say to your boss, of course I want to grow revenue, But don't we want to learn from our customers? Do not put me in a position where it is more important to get revenue than to actually learn from the customer on this. One last thing. You may need to instrument or monitor OCA so you can detect patterns of use that lend themselves to upselling and monetization. Perhaps certain kinds of customers use certain channels more frequently or differently than others, and that may represent a selling opportunity for you. I know we're running out of time. Last question, and then we'll go. Yes? Correct.
Yeah, for your presentation, right? So just I want to know, like, from your perspective, like, with Telkom, we're trying to transform to digital telcos, and
right.
According to your opinion and obviously experience, like, how does telco properly determine the use cases, like, for our, let's say, B2B customer, where previously our experience is in legacy,
right?
And then certainly digital knowledge and know-how is quite limited, right? So what's the proper way? Is it like just based on customer pain points, or can we actually also do a mix of this, like the future trend, and see whether the customer may accept that, or what's the correct way
that is
to do that?
Absolutely terrific question. Some organizations focus on eliminating pain points. I mentioned to these folks, one of the most important, I will name the company. God, it just popped out. It's the stock trading company. Oh, come on. Charles Schwab. But thank you for saying Merrill Lynch. So they did NPS, okay? But they discovered that the real issue was customer effort, and that there was a relationship between customer effort, pain point, and net promoter score. Your point is a very good one. The problem is you don't know ex ante before whether you should focus on this or that. So let me tell you the cheat that works, and it's a simple cheat. It's not an expensive cheat, and you can learn a lot. You've mentioned banks. Banks, even Indonesian banks, are technically sophisticated relative to because of the competition in mobile payments and stuff. So even though they have legacy systems, they're very aggressive in mobile. Here is my $1 million, not $1 billion, $1 million cheat. You have to start somewhere. You go to those banks and say, we will give you access to our network via an API and an SDK. You begin with do it yourself. You offer them, and you'll support them, but you don't tell them what to do. You say, here's the API, here's what you have access to. By the way, who began this way? AWS. We just saw that. Okay? You go there, you begin by marketing APIs. If nobody picks up on your APIs, that tells you something. If only a certain kind of profile picks up on APIs, that tells you something. If there are communities of people around that API, that's a business. That's a business. And somebody may come to you and say, this would work, but I can't do timestamping on the API, or it doesn't let me do this. It doesn't track the call well enough. Then you modify the API, but at least you know there's a demand there. So that is where I would begin. Begin with, and we couldn't do this a decade ago. Now you begin with make DIY, do it yourself. Simpler, cheaper, externalizable. Let the customer drive the use case instead of you. And I think we are done.
Okay, so we still have a few questions.
Oh dear, okay, all right.
From the online audience.
Yes.
So the first one, it's not a question, but it's a statement.
Oh, that's okay, I can live with that.
Yeah. So it's from Mr. Komang. He's Executive Vice President in one of our directorates of digital.
So that means I must take him seriously, yes?
Yes,
okay,
yes.
Okay.
You should.
Okay.
So he said, we have just finished metadata management, all Telkom Group.
Fantastic.
We are trying to start to monetize it.
Fantastic. That is great news. And by the way, with all due respect to him, he is not going to be the one to monetize the metadata. You are going to be. You need to have visibility into that metadata. But that is wonderful news, and that is a very good statement. Good to hear. And now the question is, how do we, forgive the phrase, democratize metadata in Telecom Indonesia? Terrific. I'm glad. Thank you so much for that.
Yes. Okay. And
Next
the
question.
next one is from Mr. Jamie. I think you will ask by Zoom.
Ah, okay. Hello again.
Yeah.
Yes, finally I can unmute the microphone. Thank you, Michael, and I'm so sorry for not pronouncing your last name correctly earlier.
Oh, it's fine, please.
And it has been a very great presentations, very insightful. We really appreciate what you have shared with us. I have two quick questions just to confirm my understanding.
Sure.
The first one, regarding the virtuous cycle, it seems that if we don't go the complete circle as a whole, then that means we are not in the right perspective or in the right understanding or business modeling to our company. So please let me know if I understand this correctly.
I'm not quite
And the
certain.
second one, yeah.
I just
And the
want to
second
make sure, I just want to
one,
make sure I
is there
understand.
any some
Go ahead.
caveat to the virtual circle? For instance, is there a time that we have to bear the money that we have to invest, the people we have to invest, to ensure that we can go all to the complete circle of the virtual circle? So for example, we may need to be very passionate to the circle to reach the complete virtual circle. We have to wait for the customer to understand. We have to ensure all employees have the same visions, any other resources that we have to invest, things like that. That's the two questions I have. And again, thank you very much for sharing with us. It has been very, very insightful. Thank you so much.
I will need help from Hamza on understanding the first question. Let me deal with the second question first. I have worked with enough large organizations, even larger than Telecom Indonesia. I do not believe you can get 100,000 people to agree or aligned. It's just, you know, I think it is very important. Alignment is very important, but how do you want to understand? Okay. I will offer the best advice I can on this. There are over 100,000 people here. We have all of these small teams. I think the healthiest conversation to have in Telecom Indonesia is the conversations I see in organizations like Amazon, like UBS. I'm not saying the answers are good. I'm saying the conversations are helpful. What does it mean to lead by example? Not how do we tell people what to do or what the best KPI is. How do we lead by example? How does our team share data, expose APIs that set an example for other people in the organization? How does leadership set an example? That to me is the most important role. And let me just say, because I'm with MIT, the best professors at MIT, their students say, my professor, it's not what he or she or they told me what to do, the way they would manage me, the way they would manage the research, they set an example for me. So that is the unit of analysis. What is the first question?
Okay, so Mr. Jamie, if you would please, boleh diulang Pak, pertanyaan yang pertama tadi, mohon maaf agak kurang jelas.
Yes, surely. I'm so sorry for not expressing the questions correctly. So we discussed about virtuous circle, right? And since it is a circle, so it should go back to the origin, right?
Circle. Yes,
we help the customer, then the customer help us. That's a very nice phrase that you have shared with us. So my question is, if we somehow cannot complete the circle, not going back to us, not going back to the origin, we help the customer, we think we help the customer, but the customer doesn't help us, meaning somewhere in the circle, it's broken, right?
Correct.
So if we cannot complete the circle, do you think we cannot really exercise the correct model of the virtuous circle? Should it always go back to the origin? Thank you very much.
Excellent. So I'm so grateful for that question, and I apologize for turning my back on you, but maybe you can see me through the not everything is going to be a virtuous cycle. Just like not everything is a product or a service. The issue is, what are the virtuous cycles that are most important for a certain group of customers right now? There will be, and I can certainly use this phrase in university, there will be a learning curve. There are probably right now 4 or 5 virtuous cycles going on in a company the size of Telekom Indonesia that you barely recognize, but if you invested a bit more, if you put an API on them, if you expose them to more people, they would become even more valuable on this. Let's begin with learning from the virtuous cycles that you have, and learning from those virtuous cycles will help you fix or adjust virtuous cycles that are broken or not as valuable or not as virtuous in the future. I believe, I'll end with one of the most important things I've learned in teaching and advising work. When I used to go to when I went to organizations, I would study them, I would study them, I would study them, and I would look at a vision, a destiny, a customer transformation that would make sense for them. And I worked so hard to give them a vision of the future that people would buy into and align to. But I discovered something, and I'm ashamed to say it took me too long to realize it. As wonderful a vision as you paint, you have to begin with where people are. And in an organization of 100,000 people, they're all over the place. We have to begin with where you are. And that is why I am focusing on these principles. Here's where I would like you to begin. How do we want to transform our customers? Okay, what are the use cases and virtuous cycles that might facilitate that? And the third is, how are we measuring value from that? So we have a KPI. Those are the principles that I suggest you begin with. I want to thank you so much for your time and attention and opportunity. It was a pleasure, but I think you deserve a break. Take care.
Okay.
Yeah, thank you very much, Professor.
Okay, thank you, Michael, for the very inspirational speech, your talk. Oke, terima kasih Bapak Ibu sekalian atas perhatiannya dan kemudian diskusinya cukup panas tadi ya. Kita juga mendapatkan banyak sekali insight dari Michael. Hopefully, I think, can we connect with you on LinkedIn? Or ya, so teman-teman kalau masih ada pertanyaan bisa gitu ya, kita bisa langsung connect dengan LinkedIn atau bisa ya, atau kita juga ada program ya, namanya MIT ILP. Nah, jadi kita bisa mengkompilir pertanyaan, bisa dikumpulkan ke panitia. Nanti kita akan kirimkan pertanyaan untuk bisa dijawab oleh para expert di sana. Ya, jadi ini merupakan salah satu bagian dari program MIT ILP dan pasnya ke depan kita juga masih ada banyak sekali expert-expert yang akan mengisi ya langsung dari MIT. Jadi tetap stay tune dan saksikan acara ini ke depan. Oke, baik. Terima kasih. Sekian dari kami. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Mr. Hamza, for leading such a constructive discussion, and Mr. Michael for sharing your invaluable insight with us. Rekan-rekan sekalian, izin kami menginfokan kembali bahwa kita akan beristirahat terlebih dahulu hingga pukul 15 WIB, di mana setelah ini kita masih ada sesi webinar yang gak kalah seru dan menarik. Jadi tetap stay tune terus rekan-rekan sekalian. Dan kami memohon kesediaan dari seluruh rekan-rekan yang hadir dan menyaksikan ITDRI ConFes 2022 saat ini Untuk mengisi survei ITDRI di bagian kanan di website icc.itdri.id, di mana ini dapat menjadi acuan dan dorongan agar ITDRI dapat terus berkolaborasi dan tentunya mengembangkan proses learning, research, hingga innovation. Sampai jumpa kembali di pukul 15 dan jangan lupa makan siang dan beristirahat. Selamat beristirahat rekan-rekan sekalian.
I'm hopeless in the crossfire. There's nowhere to go. I'm holding my desires. My heart overflows. The only direction that I'll ever need is a deeper connection that's leading me. And I'm lost in your love when you hold me. Just hold me, 'cause I don't wanna run from your heartbeat. Your heartbeat, no, 'cause I'm lost in your love. I can't break the fall, it's taking me all. I'm lost in your love. I'm lost in your love. I'm lost in your love. No words can change the future of us. The waves, they break, but we are enough. The only direction that I'll ever need is a deeper connection that's leading me. And I'm lost in your love when you hold me. Just searching for the answer to all our trials. We came so far through our weakness. We found a love, even the stars between us won't marry us. One day we can be together. And this moment could last forever. I say that you and I have found a piece of heaven. So I pray we can be together. One we found love in separate ways. Heartbreak is a wonderful price to pay. We came so far through our weakness. We found a love, even the stars between us won't marry us. One day we can be together. And this moment could last forever. I say that you and I have found a piece of heaven. So I pray we can be together. One got your number. It's hard to tell you no. I know you've got bad intentions. Oh, it feels so good to have attention. Yeah, no one has to know. No one has to know you're my guilty pleasure. Keep it on the low. Keep it on the low. You're my guilty pleasure. I know I'm not on my best behavior, but I stay here anyway. Oh, no one has to know. No one has to know you're my guilty You're the seduction. I finally reached a point. I'm the dysfunction. Just trying to fill a void. I know you've got bad intentions. Oh, it feels so good to have attention. Yeah, no one has to know. No one has to know you're my guilty pleasure. Keep it on the low. Keep it on the low. You're my guilty pleasure. I know I'm not on my best behavior, but I stay here anyway. Oh, no one has to know. No one has to know you're my guilty pleasure. I know I'm not on my best behavior, but I stay here anyway. Oh, no one has to know. No one has to know you're my guilty pleasure. Yeah. Monochrome is all I've known. Faded black, shades of white and gray. Until you colored my day. I was saying solutions, saturated shades until we washed it all away. And I'm left with black and blues. But I wanna see the skies again. The sunlight in your Sun fading, sky gazing, stars are the jewels of the night, hidden behind a horizon, into the moonlight, into the moonlight. We were chosen, hearts are frozen. We were chosen, hearts are frozen. In time, in time, in time, in time. Once upon a time, and fame was on the road. We were dreamers, free and fearless. The world beneath us, we take flight. Starlight, star bright, you are the first star I see tonight. Starlight, star bright, shine so high you light up the night. Sun fading, sky gazing, stars are the jewels of the night, hidden behind a horizon, into the moonlight, into the moonlight. We were chosen, hearts are frozen. We were chosen, hearts are frozen. In time, we are the dreamers, free and fearless. We are the dreamers, free and fearless. We are the dreamers, free and fearless. The world beneath us, we take flight. Once upon a time, and fame was on the road. We were dreamers, free and fearless. The world beneath us, we take flight.
Gotta work it out somehow. I made too many promises. I won't go back on them, no. Girl, we gotta work it out right now. I swear I'll make you love again. I'll make you love again. Yeah. If this the last thing that I say, I make sure I say it the right way. If this the last thing that I do, I make sure that I get through to you. too many promises. I won't go back on them, no. Girl, we gotta work it out right now. I swear I'll make you love again. I'll make you love again, yeah. If it's the last thing that I say, I make sure I say it the right way. If it's the last thing that I do, I make sure that I get through to you. If it's the last thing that I do, I make sure that I get through. Make sure that I get through to I wanna know who you really are, what you dream about at night. I wanna know who you really are, baby, come into the light. I wanna know you. I wanna know you. I wanna know you. I wanna know who you really are, what you dream about at night. I wanna know who you really are, baby, come into the light.
I wanna know you. I wanna know you.
I know you've been feeling me, baby. Won't you give it up? And we both know that this could be something, but that ain't enough. 'Cause when the leaves start falling down, I need to see you big around. You and me, we both live life at full speed, easy to see. When we collide, no one walks away easy. And it hurts so bad, but it doesn't mean letting go. No, 'cause after the storm, you'll see the sun, you'll see the sun.
The clock keeps ticking as the time flies by. So many times I've forgiven you in my mind. My dreams keep haunting me. I get no sleep. I keep thinking I'm in too deep. The clock keeps ticking as the time flies by. I keep thinking that I won't survive, but my body won't let me drown. Still my mind is falling down. See you Feel me in the darkness. The shadows, they follow you like an accomplice. Lost all of your dreams, the night is harder. My shadows, they follow you. My shadows, they follow you in the darkness.
think I'm falling in love. Oh yeah, yeah, yeah. I'm feeling I can't ignore. Oh yeah, yeah, you can see it in my eyes. What I'm saying is no lie, no lie, no lie, yeah, no lie. Being with you is my medicine. Being with you is my medicine. Being with you is my medicine.
I'm holding my desires, my heart overflows. The only direction that I'll ever need is a deeper connection that's leading me. And I'm lost in your love when you hold me. Just hold me, 'cause I don't wanna run from your heartbeat, your heartbeat. No, 'cause I'm lost in your love. I can't break the fall, you're taking it all. I'm lost in your love. I'm lost in your love. I'm lost in your love. No words can change the future of us. The waves, they break, but we are enough. The only direction that I'll ever need is a deeper connection that's leading me. And I'm lost in your love when you hold me. Just hold me, 'cause I don't wanna run from your heartbeat, your heartbeat. No, 'cause I'm lost in your love. I can't break the fall, you're taking it all. I'm lost in your love. I'm lost in your love. I'm lost in your love. Separated through the miles, searching for the answer to our trials. We came so far through our weakness. We found a love, even the stars between us won't marry us. One day we can be together, and this moment could last forever. I say that you and I have found a piece of heaven, so I pray we can be together one day. We found love in separate ways. Heartbreak is a wonderful price to pay. to hold you. Following the waves of your cold. But I don't wanna wait to hold you. You are my weakness. I tried to let you go. I blocked your number. It's hard to tell you no. I know you've got bad intentions. Oh, it feels so good to have attention. Yeah, no one has to know. No one has to know you're my guilty pleasure. Keep it on the low. Keep it on the low. You're my guilty pleasure. I know I'm not on my best behavior, but I stay here anyway. Oh, no one has to know. No one has to know you're my guilty pleasure. You're the seduction. I finally reached a point. I'm the dysfunction. Just trying to fill a void. I know you've got bad intentions. Oh, it feels so good to have attention. Yeah, no one has to know. No one has to know you're my guilty pleasure. Keep it on the low. Keep it on the low. You're my guilty pleasure. I know I'm not on my best behavior, but I stay here anyway. Oh, no one has to know. No one has to know you're my guilty pleasure. I know I'm not on my best behavior, but I stay here anyway. Oh, no one has to know. No one has to know you're my guilty pleasure. Yeah.
Monochrome is all I've known. Faded black, shades of white and gray, until you colored my day. I was saying solutions, saturated shades, until you washed it all away. And
Sun fading, sky gazing, stars are the jewels of the night, hidden behind a horizon, into the moonlight, into the moonlight. We were chosen, hearts are frozen. We were chosen, hearts are frozen. In time, in time, in time, in time. Once upon a time, and fables long ago, we were dreamers, free and fearless. The world beneath us, we take starlight, star bright. You are the first star I see tonight. Starlight, star bright, shine so high you light up the night. Sun fading, sky gazing, stars are the jewels of the night, hidden behind a horizon, into the moonlight, into the moonlight. We were chosen, hearts are frozen. We were chosen, hearts are frozen. In time, we are the dreamers, free and fearless. We are the dreamers, free and fearless. We are the dreamers, free and fearless. The world beneath us, we take flight. Once upon a time, and fables long ago, we were dreamers, free and fearless. The world beneath us, we take flight.
Gotta work it out somehow. I made too many promises. I won't go back on them, no. Girl, we gotta work it out right now. I swear I'll make you love again. I'll make you love again. Yeah. If this the last thing that I say, I make sure I say it the right way. If this the last thing that I do, I make sure that I get through to you.
what you dream about at night. I wanna know who you really are, baby, come into the light. I wanna know you. I wanna know you. I wanna know you. I wanna know who you really are, what you dream about at night. I wanna know who you really are, baby, come into the light. I wanna know you. I wanna know you.
I know you've been feeling me, baby. Won't you give it up? And we both know that this could be something, but that ain't enough. 'Cause when the leaves start falling down, I need to see you be around. You and me, we both live life at full speed, easy to see. When we collide, no one walks away easy. It hurts so bad, but it doesn't mean that it's wrong. No, 'cause after the storm, you'll see the sun, you'll see the sun.
The clock keeps ticking as the time flies by. So many times I've forgiven you. In my mind, no sleep. I keep thinking I'm in too deep. The clock keeps ticking as the time flies by. I keep thinking that I won't survive, but my body won't let me drown. Still my mind is falling down.
Why you lovers cry when they're apart, and they risk their lives just to spend the day. And I feel your body next to my body. Can we both freeze this moment in time? And I see us wrapped in the moonlight. Put your hands inside of mine. And I used to see you better, love you more than anybody. Never saw beauty in effort, only saw the flaws inside me. Only saw the flaws inside me. Why you lovers cry when they're apart, and they risk their lives just to spend the day. And I feel your body next to my body. Can we both freeze this moment in time? And I see us wrapped in the moonlight. Put your hands inside of mine. And I used to see you better, love you more than anybody. Never saw beauty in effort, only saw the flaws inside me. Only saw the flaws inside me. You like to play your own game. Cover it up, don't let them know what you're thinking. I bet you never tell them how it feels. I bet you never even try to be real.
Feel me in the darkness. The shadows, they follow you like an accomplice. Lost all of your dreams, the night is heartless. My shadows, they follow you. My shadows, they follow you in the darkness.
think I'm falling in love. Oh yeah, yeah, yeah. I'm feeling I can't ignore. Oh yeah, yeah, you can see it in my eyes. What I'm saying is no lie, no lie, no lie, yeah, no lie. Being with you is my medicine. Being with you is my medicine. Being with you is my medicine.
there's nowhere to go. I'm holding my desires, my heart overflows. The only direction that I'll ever need is a deeper connection that's leading me. And I'm lost in your love when you hold me. Just hold me, 'cause I don't wanna run from your heartbeat. Your heartbeat, no, 'cause I'm lost in your love. I can't break the fall, you're taking it all. I'm lost in your love. 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 Lost in your I'm lost in your No words can change the future of us. The waves, they break, but we are enough. The only direction that I'll ever need is a deeper connection that's leading me. And I'm lost in your love when you hold me. Just hold me, 'cause I don't wanna run from your heartbeat. Your heartbeat, no, 'cause I'm lost in your love. I can't break the fall, you're taking it all. I'm lost in your love. 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 Lost in your love. I'm lost in your
Separated through the miles, searching for the answer to our trials. We came so far through our weakness. We found a love, even the stars between us won't marry us. One day we can be together, and this moment could last forever. I say that you and I have found a piece of heaven, so I pray we can be together one day. We found love in separate ways. Heartbreak is a one
to let you go. I blocked your number. It's hard to tell you no. I know you've got bad intentions. Oh, it feels so good to have attention. Yeah, no one has to know. No one has to know you're my guilty pleasure. Keep it on the low. Keep it on the low. You're my guilty pleasure. I know I'm not on my best behavior, but I stay here anyway. Oh, no one has to know. No one has to know you're my guilty You're the seduction. I finally reached a point. I'm the dysfunction. Just trying to fill a void. I know you've got bad intentions. Oh, it feels so good to have attention. Yeah, no one has to know. No one has to know you're my guilty pleasure. Keep it on the low. Keep it on the low. You're my guilty pleasure. I know I'm not on my best behavior, but I stay here anyway. Oh, no one has to know. No one has to know you're my guilty pleasure. I know I'm not on my best behavior, but I stay here anyway. Oh, no one has to know. No one has to know you're my guilty pleasure. Yeah. Monochrome is all I've known. Faded black, shades of white and gray. Until you colored my day. I was seeing solutions, saturated shades until you washed it all away. And choose out the night, hidden behind a horizon, into the moonlight, into the moonlight. We were chosen, hearts are frozen. We were chosen, hearts are frozen. In time, in time, in time, in time. Once upon a time, and fame was on the road. We were dreamers, free and fearless. The world beneath us, we take starlight, star bright. You are the first star I see tonight. Starlight, star bright. Shine so high, you light up the night. Sun fading, sky gazing. Stars are the jewels of the night. Hidden behind a horizon, into the moonlight, into the moonlight. We were chosen, hearts are frozen. We were chosen, hearts are frozen. In time, we are the dreamers, free and fearless. We are the dreamers, free and fearless. We are the dreamers, free and fearless. The world beneath us, we take life. Once upon a time, and fame was on the road. We were dreamers, free and fearless. The world beneath us, we take life.
Gotta work it out somehow. I made too many promises. I won't go back on them, no. Girl, we gotta work it out right now. I swear I'll make you love again. I'll make you love again. Yeah. If this the last thing that I say, I make sure I say it the right way. If this the last thing that I do, I make sure that I get through to you. If this the last thing that I do, I make sure that I get through. Make sure that I get through to you. Gotta work it out somehow. too many promises. I won't go back on them, no. Girl, we gotta work it out right now. I swear I'll make you love again. I'll make you love again. Yeah. If it's the last thing that I say, I make sure I say it the right way. If it's the last thing that I do, I make sure that I get through to you. If it's the last thing that I do, I make sure that I get through. Make sure that I get through to I wanna know who you really are, what you dream about at night. I wanna know who you really are, baby, come into the light. I wanna know you. I wanna know you. I wanna know you. I wanna know who you really are, what you dream about at night. I wanna know who you really are, baby, come into the light.
I wanna know you. I wanna know you.
I know you've been feeling me, baby. Won't you give it up? And we both know that this could be something, but that ain't enough. 'Cause when the leaves start falling down, I need to see you be around. You and me, we both live life at full speed. Easy to see when we collide, no one walks away easy. It hurts so bad, but it doesn't mean that it's wrong. No, 'cause I feel the storm. You'll see the sun. You'll see the sun.
The clock keeps ticking as the time flies by. So many times I've forgiven you in my mind. My dreams keep haunting me. I get no sleep. I keep thinking I'm in too deep. The clock keeps ticking as the time flies by. I keep thinking that I won't survive, but my body won't let me drown. Still my mind is falling down. Feel me in the darkness. The shadows, they follow you like an accomplice. Lost all of your dreams, the night is harder. My shadows, they follow you. My shadows, they follow you in the darkness. crossfire, there's nowhere to go. I'm holding my desires, my heart overflows. The only direction that I'll ever need is a deeper connection that's leading me. And I'm lost in your love when you hold me. Just hold me, 'cause I don't wanna run from your heartbeat. Your heartbeat, no, 'cause I'm lost in your love. I can't break the fall, you're taking it all. I'm lost in your love. I'm lost in your love. I'm lost in your love. I'm lost in no words can change the future of us. The waves, they break, but we are enough. The only direction that I'll ever need is a deeper connection that's leading me. And I'm lost in your love when you hold me. Just hold me, 'cause I don't wanna run from your heartbeat. Your heartbeat, no, 'cause I'm lost in your love. I can't break the fall, you're taking it all. I'm lost in your love. 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 Lost in your love. I'm lost in your
Separated through the miles, searching for the answer to our trials. We came so far through our weakness. We found a love, even the stars between us won't marry us. One day we can be together, and this moment could last forever. I say that you and I have found a piece of heaven, so I pray we can be together one day. We found love in separate ways. Heart
tried to let you go. I blocked your number. It's hard to tell you no. I know you've got bad intentions. Oh, it feels so good to have attention. Yeah, no one has to know. No one has to know you're my guilty pleasure. Keep it on the low. Keep it on the low. You're my guilty pleasure. I know I'm not on my best behavior, but I stay here anyway. Oh, no one has to know. No one has to know you're my guilty You're the seduction. I finally reached a point. I'm the dysfunction. Just trying to fill a void. I know you've got bad intentions. Oh, it feels so good to have attention. Yeah, no one has to know. No one has to know you're my guilty pleasure. Keep it on the low. Keep it on the low. You're my guilty pleasure. jewels of the night, hidden behind a horizon, into the moonlight, into the moonlight. We were chosen, hearts are frozen. We were chosen, hearts are frozen. In time, in time, in time, in time. Once upon a time, and fame was on the road. We were dreamers, free and fearless. The world beneath us, we take flight. Starlight, star bright, you are the first star I see tonight. Starlight, star bright, shine so high you light up the night. Sun fading, sky gazing, stars are the jewels of the night, hidden behind a horizon, into the moonlight, into the moonlight. We were chosen, hearts are frozen. We were chosen, hearts are frozen. In time, we are the dreamers, free and fearless. We are the dreamers, free and fearless. We are the dreamers, free and fearless. The world beneath us, we take flight. Once upon a time, and fame was on the road. We were dreamers, free and fearless. The world beneath us, we take flight.
Gotta work it out somehow. I made too many promises. I won't go back on them, no. Girl, we gotta work it out right now. I swear I'll make you love again. I'll make you love again, yeah. If this the last thing that I say, I make sure I say it the right way. If this the last thing that I do, I make sure that I get through to you. If this the last thing that I do, I make sure that I get Gotta work it out somehow. too many promises. I won't go back on them, no. Girl, we gotta work it out right now. I swear I'll make you love again. I'll make you love again. Yeah. If it's the last thing that I say, I make sure I say it the right way. If it's the last thing that I do, I make sure that I get through to you. If it's the last thing that I do, I make sure that I get through. Make sure that I get through to you. I wanna know who you really are, what you dream about at night. I wanna know who you really are, baby, come into the light. I wanna know you. I wanna know you. I wanna know you. I wanna know who you really are, what you dream about at night. I wanna know who you really are, baby, come into the light.
I wanna know you. I wanna know you.
I know you've been feeling me, baby. Won't you give it up? And we both know that this could be something, but that ain't enough. 'Cause when the leaves start falling down, I need to see you be around. You and me, we both live life at full speed, ETC. When we collide, no one walks away easy. It hurts so bad, but it doesn't mean that no, 'cause I feel the storm. You'll see the sun, you'll see the sun.
The clock keeps ticking as the time flies by. So many times I've forgiven you in my mind. My dreams keep haunting me. I get no sleep. I keep thinking I'm in too deep. The clock keeps ticking as the time flies by. I keep thinking that I won't survive, but my body won't let me drown. Still my mind is falling down.
Tes.
Selamat siang rekan-rekan sekalian. Pertama-tama saya mau dengar dulu nih, mana semangat rekan-rekan pada siang hari ini sebelum kita akan mulai untuk sesi selanjutnya. Kalau saya bilang semangat pagi, rekan-rekan jawabnya pagi, pagi, pagi. Ayo kita coba nih. Semangat pagi, 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 pagi. Jadi walaupun waktu sudah menunjukkan pukul 15 WIB, tapi semangat rekan-rekan sekalian ini masih semangat pagi hari. Selamat siang dan selamat datang saya ucapkan kepada Telkomers, partner TCUC ITDRI dan juga rekan-rekan yang turut hadir dan menyaksikan ITDRI ConFes 2022. Kembali lagi dengan saya, Natasha Gabriela Kastanya. Gimana nih istirahatnya dan makan siangnya, apakah sudah cukup? Semoga sudah cukup nih ya rekan-rekan sekalian. Karena walaupun sudah siang menjelang sore, kita harus tetap semangat. Karena kita akan mendengarkan sesi webinar yang akan mengulas materi yang sangat menarik dan gak kalah seru dengan webinar sebelumnya. Baiklah, sebelum kita lanjut ke sesi berikutnya, kami mau mengingatkan kembali kepada rekan-rekan sekalian bahwa kami membuka sesi tanya-jawab dengan para pembahas. Jadi buat rekan-rekan yang ingin memberikan pertanyaan maupun tanggapan, dapat langsung mengisi di kolom chat box dengan format nama, institusi, tujuan narasumber, dan juga pertanyaan. Pada sesi terakhir hari ini, kita akan mengulas topik yang tentunya menjadi salah satu bagian dari 8 digital driver yang dapat merubah perilaku pasar dan akhirnya menuntut perubahan perilaku pelaku bisnis, yang dimana salah satunya merupakan hasil dari task force B20 yang dipimpin oleh Telkom, yaitu ialah Internet of Things atau yang kita kenal dengan IoT, dan pada sesi ini akan dispesifik lagi untuk dibahas yaitu terkait dengan Internet of Things for Dummies. Dengan pembicara kita pada sesi kali ini yaitu Mas Brian Ganda Pratama selaku CEO Evomo dan juga akan didampingi oleh Mas Fahmi Hidayatullah selaku CTO dari Evomo. Dan untuk memandu sesi pada siang hari ini ada Mas Marcelinus Jastian yang akan bertindak selaku moderator. Baik, langsung saja kami persilahkan kepada Mas Jastian.
Ya, terima kasih Mbak Natasha. Selamat siang, Telkomers, para partner ITDRI. Kembali lagi bersama saya, Justian, di sesi kali ini, yaitu Internet Things for Dummies. Nah, tidak kalah seru dari sesi sebelumnya, kali ini kita akan membahas topik ini bersama pakarnya, yaitu Mas Brian Ganda Pratama dan Mas Fahmi Hidayatullah. Selamat siang, Mas Brian dan Mas Fahmi. Apa kabar, Mas? Sehat?
Siang, Mas. Sehat-sehat.
Sedikit saya akan membacakan CV dari Mas Brian dan Mas Fahmi. Nah, Mas Brian ini dari tahun 2002 sampai saat ini pernah memiliki pengalaman sebagai inovator, lalu pada tahun 2020 sampai tahun 2002 sebagai junior expert inovator di Telkom Indonesia dan merupakan founder dari Evomo ID. Selain itu, Mas Brian juga memiliki sertifikat lisensi itu dari Makpus Institute, CPM Asia Best 57, dan juga dari IDX Verified Certificate for the Value of Business Models. Nah, kalau Mas Fahmi nih, Mas Fahmi dari 2016 sampai saat ini itu sebagai inovator di PT Telkom Indonesia dan juga pernah sebagai staff IT and Business Process Improvement dari tahun 2015 sampai 2016. Nah, Mas Fahmi juga punya sertifikat Alibaba Cloud Certified pada tahun 2022 dan Google Cloud Certified pada tahun 2020. Nah, itu sedikit background dari pembicara kita kali ini, yaitu Mas Brian dan Mas Fahmi. Mungkin para Telkomers dan partner ITDRI tidak sabar nih tentang apa sih yang mau dibahas kali ini. Nah, mari silakan Mas Brian dan Mas Fahmi bisa dimulai mengenai topik yang sangat menarik. Silakan Mas Brian dan Mas Fahmi.
Ya, terima kasih Mas. Mungkin bisa cek. Oke, sip. Oke, next langsung aja. Oke, nah di sini di pertama kali kita langsung lihat data ya. Ini pertanyaan cukup menarik. Kenapa sih industri 4.0 gitu? Kenapa industri 4.0 terus digadang-gadang ya di seluruh acara ataupun event internasional terkait dengan teknologi gitu. Dan ternyata kita harus tahu juga gitu dari data ini ya, di tahun 2011 itu gitu ya. 2011 itu ternyata Jerman itu punya tim research yang dimana pemerintahnya itu pengen supaya negaranya itu maju dengan sebuah teknologi. Oleh sebab itu, tim ini mencetuskan yang namanya industri 4.0 gitu. Namun dari tahun ke tahun belum booming gitu ya. Dari 2019 belum naik terus ya trennya terkait dengan industri 4.0. Orang masih menganggap apa sih ini industri 4.0? Ada yang menganggap ini adalah sebagai gimmick marketing gitu ya, industri 4.0 itu. Nah, ternyata di tahun 2014 sampai 2015 ada salah satu orang yang bernama Klaus gitu ya. Klaus ini adalah seorang profesor ya, seorang profesor yang membawakan ide ya, ide terkait dengan industri 4.0 di World Economic Forum. Dan ternyata di acara ini, di event ini, semua pada aware gitu ya, pada tahu, oh ternyata benefit industri 4.0 itu ternyata lebih ke efisiensi gitu. dan bagaimana cara membuat para di sini industri manufacture atau industri lainnya itu lebih menguntungkan gitu. Jadi banyak sisi positifnya dibandingkan negatifnya. Nah, oleh sebab itu pada tahun yang sama banyak sekali ya, dari mulai tahun 2015, kalau dilihat di sebelah kanan bawah itu ada academic research paper gitu ya, yang terkait dengan industri 4.0 itu mulai naik gitu. Jadi banyak akademisi yang mencoba untuk mencari terkait dengan resep industri 4.0 ya, mulai dari AI, mulai dari IoT, kemudian mulai dari machine learning dan lain sebagainya. Jadi mulai naik itu trennya. Dan secara tidak sadar ini membangun perekonomian digital, terutama pemain-pemain teknologi. Kalau di Indonesia contohnya Evomo gitu ya. Nah, Evomo di sini mulai tertarik juga untuk masuk. Halo? Halo, cek. Halo?
Terdengar, Mas? Terdengar.
Masuk ya? Oke.
Masuk.
Oke. Halo?
Masuk, Mas Budian?
Halo? Sorry.
Ya.
Oke, sorry. Oke, aku lanjut ya, sorry. Oke, ternyata ada dual meeting sambung jadi satu, maaf. Jadi aku lanjut ya. Jadi academic research paper ya di industri 4.0 mulai naik gitu ya, banyak yang research gitu ya. Dan ternyata ini membawa angin segar bagi pemain teknologi. Ya. Jadi kurang lebih itu terkait dengan historicalnya, pertama kali dicetuskan oleh di negara Jerman, kemudian dibawa keluar oleh Profesor Klaus, kemudian mulai naik traffic-nya, dan pemain-pemain teknologi sekarang masuk untuk membuat industri 4.0 ini menjadi lebih nyata dan applicable. Gitu. Next. Oke. Nah, tadi aku bilang bahwa ternyata ini membawa angin segar bagi pelaku industri ya. Kalau dilihat di sini ada enterprise IoT market. Apa sih kaitannya industri 4.0 sama IoT? Sebenarnya IoT itu adalah salah satu bagian dari industri 4.0, salah satu enabler-nya. Jadi industri 4.0 itu ada banyak sekali teknologi dan salah satunya itu IoT. Nah, di kali ini kita akan bahas sub yang IoT-nya. Kalau dari segi marketnya IoT gitu ya, di sini bisa dikelihatan juga ya. Di tahun 2021 kita cek ya, IoT security nilainya 4%, IoT hardware itu nilainya 35%, kemudian IoT service itu 36%, kemudian ada IoT software itu nilainya 26% ya. Nah, kalau dilihat di sini porsi yang paling besar itu di hardware, kemudian di IoT services. Nah, bagi pelaku industri ataupun enterprise, hardware itu merupakan modal yang paling besar gitu ya. Jadi harus beli dulu ya perangkat-perangkat keras. Jujur aja kalau mau investasi terkait dengan implementasi IoT, kemudian mau menuju ke roadmap industri 4.0, memang membutuhkan modal yang cukup besar, apalagi sebuah perusahaan gitu ya. Karena itu masuk ke anggaran ke capex-nya. Nah, kalau dilihat di sini proporsi di tahun 2021 selain hardware juga ada IoT service. IoT service ini maksudnya juga dimaksud IoT infrastruktur ya. Jadi seperti cloud, infrastruktur cloud itu juga cukup lumayan besar gitu ya. Dan juga disusul dengan IoT software gitu ya. IoT software ini macam-macam kalau di enterprise ya, bisa pakai yang model paling tinggi yaitu pakai SAP ya, ataupun custom dengan menggunakan framework software yang ada saat ini. Misal kalau di front end bisa pakai React atau di back end-nya pakai Golang gitu ya. Jadi kelihatan memang di tahun 2021 proporsinya seperti yang ada di grafik, dan kita lihat forecasting-nya dari tahun ke tahun itu meningkat gitu ya, meningkat. Dan dipastikan memang bagi pelaku industri IoT ini merupakan lahan ataupun bidang yang seksi. Karena semakin terus didengungkan oleh media-media, oh kita beralih ke industri 4.0. Makanya pelaku industri juga mulai naik juga karena terangkat oleh media-media yang menggadang-gadang industri 4.0. Di sini kelihatan ya pertumbuhan dari CAGR-nya yang terus meningkat. Next. Nah, tadi aku sudah bilang ya, industri 4.0 adalah sebuah gabungan-gabungan gitu ya. Dan kalau dilihat ternyata yang paling besar untuk saat ini itu adalah artificial intelligence. Nah, kalau diamat-amati ya, mungkin teman-teman tahu juga ya, ada salah satu AI company yang sudah mengeluarkan produknya yaitu Open AI gitu ya. Open AI, dan teman-teman bisa coba di platform mereka ya untuk chat Open AI. Itu merupakan salah satu platform yang AI-nya sangat-sangat bagus ya. Dan itu kalau diimplementasikan, apalagi ngambil API-nya OpenAI dan disesuaikan dengan use case masing-masing enterprise, itu bakalan membantu sekali. Jadi artificial intelligence ini sangat-sangat membantu ya. Itu bobotnya 16%, dan banyak sekali startup-startup di luar sana yang juga masuk ke AI. Kemudian yang selanjutnya ada human augmented dan extended reality ya. Mungkin kalau bahasa kerennya metaverse gitu ya. Sekarang lagi gadang-gadang metaverse, namun kalau dilihat dari sahamnya Meta turun gitu ya. Kalau dilihat memang secara teknologi metaverse itu hal yang baru ya. Kalau di industri manufaktur biasanya dipakai untuk gitu. Jadi instead of kita, ini ada edge, kemudian ada cloud computing. Nah, ini bobotnya 11%. Hal yang menarik di sini adalah segala sesuatu yang terkait dengan pemrosesan citra itu pada akhirnya akan bermuara di embedded systemnya, gitu ya. Dalam hal artian gini, kalau kita mau nge-tracking objek manusia gitu ya, kalau kita mau nge-tracking objek manusia ya, yang kita butuhkan adalah biasanya ya, itu adalah kamera, kemudian ada server ya, server yang khusus untuk mengubah image itu menjadi sebuah parameter. Misal, kalau misalnya ada kedeteksi manusia nih, ini wajahnya siapa, itu ketahuan, wajahnya si B, misal kayak gitu. Nah, ini ada dua hal di sini gitu. Nah, kalau edge computing itu semuanya jadi satu gitu. Itu di kameranya semua. Nilainya cukup, kalau dari segi harga, segi cost itu lebih murah gitu, kalau di edge computing. Nah, mungkin salah satu pengalaman ya yang menarik itu adanya M5 Stack ya. Pengalaman mereka ngembangin salah satu edge computing pakai embedded yang sederhana gitu ya. Model-model ARM gitu ya, ARM Cortex M7 gitu ya. Itu udah bisa deteksi seperti itu. Nah, itu yang terkait dengan edge computing ya, yang dimana nilainya pakai Nvidia Jetson gitu, mungkin harganya bisa sampai 10 juta, pakai edge computing cuma 1 juta aja untuk hardware-nya. Nah, kemudian ada network and connectivity, kemudian ada advanced robotic, big data analytics, kemudian ada Internet of Things. Nah, Internet of Things, aku tekankan lagi, ini di luar dari HP atau laptop kita yang terhubung dengan internet. Jadi lebih kaitannya ke embedded gitu. Jadi kita bisa memonitoring suhu rumah kita, ataupun kalau di skala industri kita bisa menghitung suhu yang ada di chamber pengolahan gitu ya. Jadi kaitannya lebih ke embedded sistemnya gitu. Dan banyak sekali use case terkait dengan Internet of Things yang tentunya disesuaikan dengan kebutuhan dari bisnis enterprise. Gitu ya. Dan lain sebagainya ada 3D printing, security, transparency, kemudian ada digital twin. Nah, ini cukup menarik ya. Kalau para konsultan-konsultan itu biasanya pada menggebu-gebu ya terkait dengan digital twin. Cuma di sini nilainya 5% ya. Jadi dalam artian masih terlalu jauh ya digital twin ya. Semua itu sudah tercombine dengan baik, semuanya sudah otomatis, itu masih jauh sekali gitu. Nah, berikut ya terkait dengan top industri 4.0 dan inovasi di tahun 2022. Kalau forecast-nya di tahun 2023 nggak terlalu jauh ya. Yang paling besar pasti artificial intelligence. Kalau teman-teman lihat berita ya, ada startup-nya punyanya Elon Musk, itu namanya Neuralink. Mereka udah berhasil membuat sebuah chipset ya. Chipsetnya itu mau ditanamkan di otaknya manusia gitu ya. Dan itu cukup luar biasa ya, tinggal menunggu FDA approval gitu ya. Itu cukup menarik itu, Neuralink gitu. Jadi apa ya, semua itu memori itu udah ada di otak semua gitu. Dan takutnya lagi kita bisa dikontrol tuh sama Neuralink gitu ya. Tapi positif side-nya kita bisa nambah memori kita gitu, dan pemrosesan akan dibantu dengan AI gitu. Itu yang cukup menarik gitu. Di tahun 2023 nanti ya. Kita akan lihat FDA proposal itu akan seperti approval itu akan seperti apa. Next. Nah, kaitannya dengan IoT gitu ya. Sekali lagi, pertanyaannya adalah gimana sih cara menerapkan industri 4.0 di IoT ya. Nah, kalau kita berkaca salah satu teknologi provider ya, ini bagian dari Siemens gitu ya. Mereka itu berawal dari hardware dulu gitu. Jadi di sini aset, contoh kalau kita di industri manufaktur, aset ini berupa mesin-mesin produksi ya. Ada mesin filler, ada mesin packaging, dan lain sebagainya. Nah, dari sini akan dimasukkan sebuah field ataupun control level. Nah, ini ibaratnya itu gateway gitu ya. Ibaratnya sebuah gateway, dan di mana dijembatani oleh sebuah protokol. Protokolnya itu macam-macam kalau di industri manufaktur ya. Dan salah satu yang umum itu biasanya Modbus RS485. Dan kalaupun yang udah upgrade versi terbaru, biasanya OPC UA gitu ya. Nah, dari data-data mesin, kemudian masuk ke gateway, kemudian barulah diolah di enterprise level gitu ya. Di enterprise level mau apa gitu ya. Dalam artian, enterprise level mau apa sih gitu. Untuk mengetahui kondisi mesin asetnya, atau mau mengefisiensi mesin aset-asetnya. Nah, biasanya akan dibuatkan aplikasi tersendiri gitu di enterprise level. Ataupun bisa langsung masuk ke SAP, kurang lebih seperti itu. Nah, biasanya selain enterprise level ada yang industrial IoT yang nomor 4 ini. Nah, biasanya juga kalau IoT di manufaktur di Indonesia kebanyakan on-premise gitu ya. On-premise dalam artian servernya itu ada di pabrik gitu. Namun sekarang ini kita ngarahinnya ke cloud, dan di sini ada banyak sekali IoT infrastruktur yang didukung untuk IoT ya. Ada salah satunya ada AWS, kemudian ada Azure juga gitu ya, dan kalau di Telkom ada Flow Cloud gitu ya, ataupun kalau yang dari China ada Alibaba Cloud gitu ya, dan banyak sekali. Sekarang cloud infrastruktur itu sangat-sangat mendukung sekali terkait dengan adanya IoT, karena data-data yang real time yang kemudian di stream gitu. Next. Oke, mungkin Mas Fahmi mau jelasin nih, silakan Mas Fahmi.
Boleh. Siap, terima kasih. Karena tadi Mas Brian cukup banyak menjelaskan tentang ini ya, peluang-peluang yang ada di IoT gitu. Saya coba pertajam ya terhadap use case yang bisa kita implementasikan. Oke ya. Kalau kita bicara IoT pada dasarnya, gitu ya, tidak pasti melekat pertama ya adanya device, gitu kan. Device ini termasuk hardware, mesin, sensor, dan sebagainya, apapun itu device-nya. Di sini device bisa macam-macam ya, kamera itu juga termasuk device di area yang connected product itu ya device ya. Kemudian juga misalnya ada secondary sensing kayak sensor infrared, kemudian proximity, water temperatur dan sebagainya itu di area device. Kemudian IoT juga pasti tidak melekat yang namanya network ya. Bagaimana dia terhubung gitu ya. Area ini kita anggap dimasukin sebagai edge control gitu ya. Nah, connectivity itu kita bisa dua arah juga kita bisa lakukan nih. Area tersebut juga bisa diimplementasikan yang namanya human machine input. Jadi bagaimana manusia itu bisa melakukan interaksi terhadap mesin. Misal mengatur kecepatan dan sebagainya itu di area operation dashboard gitu ya. Itu juga bisa langsung terintegrasi terhadap connected product atau device tadi. Nah, di layer atasnya ya adalah application. Nah, di sini meliputi aplikasi-aplikasi yang bisa kita gunakan menggunakan IoT gitu ya, ataupun analitik-analitik yang kita bisa lakukan gitu. Nah, kita coba pertajam ya bahwa ini juga bisa kita implementasikan di area FMCG ya, food, manufaktur gitu ya, di area farmasi. Kemudian mungkin untuk area ini ya, infrastruktur, water infrastruktur seperti PPAM dan sebagainya, PLN, electricity gitu ya. Atau di area mining ya, ataupun di ranges. Jadi semua area ini bisa seperti itu. Contoh di manufaktur ya, ada istilahnya operator untuk melakukan monitoring terhadap kondisi mesin atau kemudian untuk proses controlling. Oke. Jadi ataupun di area oil and gas ya, energy management, bagaimana energi yang sudah digunakan untuk kemudian menghasilkan sebuah produk ataupun terhadap profitability. Berapa banyak losses yang terjadi itu bisa kita implementasi juga dalam aplikasi yang terintegrated seperti itu. Yang pasti untuk connectivity terhadap mesin kita bisa macam-macam ya, ada connectivity dari SCADA ataupun Modbus tadi yang disampaikan oleh Brian, ataupun yang mesin-mesin yang memang sudah menghasilkan data-data yang bisa kita langsung integratekan seperti itu. Ataupun kita bisa tambah yang namanya secondary sensing di sini, sensor-sensor tambahan yang untuk mendukung implementasi IoT kita. Nah, nextnya bagaimana kita bisa mengimplementasi atau apa yang sudah dilakukan Evomo. Next saja, Mas. Oke, mungkin di slide dulu, next dulu deh. Udah benar ya, oh ya ini, sorry. Tadi Mas Bilang sudah menyampaikan bahwa kita memiliki banyak IoT infrastructure cloud platform gitu ya, yang cukup banyak. Aku coba ambil 3 aja, yang mana itu market share-nya cukup gede, yaitu AWS, Azure, sama GCP. Nah, dari ketiganya ini mungkin yang paling banyak service yang kita bisa gunakan itu AWS ya. Nanti aku akan jelasin sedikit. Tapi at least tetap bahwa IoT cloud platform itu tidak tertutup dari at least minimal 3 ya. Application management, device management, kemudian data management. Nah, itu yang harus kita pahami di IoT ini. Di application management bagaimana kita para developer itu bisa gitu ya menggunakan atau mengembangkan IoT aplikasinya. Contoh misalnya di remote monitoring, kita ingin melakukan remote terhadap sebuah mesin, mematikan dari jauh-jauh dan sebagainya. Atau kalau kita sekarang kenal itu misalnya ini ya, Birdie lah ya gampangnya, yang kita bisa menyalakan lampu dari device kita, mobile kita gitu kan. Itu adalah salah satu contoh yang kita bisa gunakan di application management. Di AWS banyak ya, misalnya AWS IoT Events, misalnya ketika data sensor mencapai titik tertentu, event apa yang bisa terjadi, mati lampu atau sebagainya gitu ya. Atau Twin Maker tadi ya, Twin Maker tadi yang disampaikan Mas Bian, Digital Twins, itu disupport juga oleh AWS gitu. Gitu. Kemudian di device management pasti bagaimana ya kita bisa memastikan bahwa things ataupun device-device tadi itu bisa terkoneksi dengan bagus. Itu ya. Pasti di AWS ada device management, kalau di Google ada IoT Core seperti itu. Tapi itu di Google Core juga IoT Core bisa semuanya lah, tapi memang nggak terlalu spesifik untuk IoT. Oke, di data management setidaknya kita di AWS kita juga bisa melakukan yang namanya analyze terhadap data real time gitu ya. Ataupun kita juga bisa menggunakan itu untuk analitik lanjutan seperti itu. Atau di sisi lain beberapa provider juga menyediakan ini ya, kalau kita mau built-in hardware sendiri ada ini ya, RTOS, Real Time Operating System. Jadi itu juga udah disupport oleh AWS ataupun Azure, sehingga kalau kita memiliki device tertentu dengan mudah connect terhadap arsitektur AWS ataupun Azure. Pun termasuk beberapa support IoT untuk security-nya ya, security device. Itu. Lanjut. Aku coba tambahkan, lanjut Mas. Oke. Aku coba tambah service-nya bahwa di area site gitu ya, mesin-mesin terconnected banyak protokol ini gateway, sehingga kita bisa tarik datanya untuk kemudian kita olah di cloud kita. Nah, cloud kita ketika udah masuk ke cloud kita udah bisa menggunakan macam-macam ya. Contoh di area operasional matrix gitu ya, para operator bisa melihat monitoring, misalnya mesin A gitu ya, suhunya maksimal apa enggak dan sebagainya. Nah dari situ kita juga bisa tambahkan namanya rules yang bisa kita gunakan untuk notify kita, misalnya nih ada alarm management. Pada kondisi tertentu pada titik tertentu kita harus segera melakukan action gitu ya. Nah, dari situ kita ada Amazon SNS untuk melakukan notifikasi terhadap kita berikan ke operator ataupun production supervisor juga sih pada dasarnya gitu ya. Seperti itu. Ataupun untuk para data scientist gitu ya. Dari paket data yang sudah kita miliki, kita taruh di data lake misalnya kayak di S3 ataupun kita masukin ke warehouse kita menggunakan Amazon Redshift itu. Nah, para BI kita juga bisa melakukan ya reporting ataupun analytical proses control dan seterusnya gitu. Itu yang bisa kita implementasi kalau kita menggunakan AWS. Tapi ini kan pasti kembali lagi ke kebutuhan ya. Bisa jadi kita cuma menerapkan sedikit bagian gitu, it's okay gitu. Yang penting bahwa proses bisnis itu terjawab dengan teknologi yang kita miliki untuk mendukung bisnis seperti itu. Lanjut. Ini Mas Wil mau menambahkan ini atau?
Iya, namun sebelum menambahin ini mau sharing juga Mas. Di Telkom itu ada yang lebih simpel lagi Mas. Jadi teman-teman kalau nggak mau ribet terkait dengan cloud yang begitu ribet tadi ya, banyak bagiannya sana sini, di Telkom itu udah ada IoT platform namanya Antares. Nah, teman-teman bisa cek langsung ke websitenya di antares.id. Kalau nggak mau ribet kayak tadi ya, karena yang tadi itu memang khusus yang benar-benar enterprise banget gitu ya. Namun kalau teman-teman butuh use case yang tidak terlalu kompleks gitu ya, teman-teman bisa pakai antares.id. Di situ juga sangat-sangat mumpuni ya. Dan juga sudah diterapkan juga di industri manufaktur. Jadi teman-teman bisa pakai antares.id. Nah, kalau kita sekarang akan berbicara nih, tadi kan udah belajar mengenai sejarahnya industri 4.0, manfaatnya, benefitnya, apa yang jadi tech emerging-nya. Nah, sekarang penerapannya industri 4.0 kalau di industri itu seperti apa sih gitu. Nah, di sini kita ngelihat ya dari market size gitu ya, dari market size, kemudian dari CAGR-nya ternyata yang paling cepat balik modal itu yang augmented operation gitu ya. Kalau dilihat yang paling ujung kanan itu yang augmented operation ya, yang dimana kalau kita nge-training orang gitu ya dengan VR gitu ya, itu kan lebih cost gitu ya, cost savingnya lebih gede gitu ya, daripada kita beli barang fisik gitu ya, kemudian kita oprek-oprek, habis itu nggak bisa dipakai gitu ya, jadi lebih applicable untuk yang augmented operation, untuk yang use case industri 4.0. Nah, namun terkait dengan market yang besar, apalagi pemain-pemain IoT akan ngincernya yang advanced digital product development. Ada dua hal yang berbeda ya. Dari segi teman-teman pelaku industri, itu akan milih ke augmented operation. Bagi pemain yang menciptakan teknologi akan milih yang advanced digital product development. Nah, salah satunya FOMO itu ngambil yang digital product development, dan di sini cakupannya juga terkait dengan performance, orchestration, kemudian predictive maintenance, dan juga memonitoring apa yang ada di lini produksi di mesin-mesin pabrik. Nah, detailnya next. Nah, kita nyebutnya OEE gitu ya. Kalau di manufaktur gitu, salah satu use case yang paling penting di industri 4.0 itu adalah OEE. Silakan Mas Fahmi, detailnya seperti apa?
Oke, kembali lagi. Ya, tadi benar yang disampaikan bahwa FOMO hadir menjembatani dari ini ya, prediksi atau use case yang kita bisa kembangkan gitu ya. Kita ingin ya intinya kita mendevelop untuk membantu manufaktur mendigitalkan proses bisnisnya gitu. Tadi sudah disampaikan juga dari OE kita berharap ya, bisa melakukan yang namanya predictive maintenance. Nanti kayak gimana predictive maintenance saya juga jelaskan. Kemudian misalnya data driven quality control gitu. Nah, tapi berangkat dari situ harapannya kita bisa menganalisis terhadap area produksi manufaktur ya. Salah satunya menggunakan yang namanya matrix OEE. Apa itu OEE? Overall Equipment Effectiveness. Jadi gampangnya adalah ini adalah sebuah KPI ya, kalau kita biasanya KPI terhadap mesin menghasilkan sebuah barang. Ibaratnya para pelaku pemilik modal itu udah invest cukup besar di mesin dia. Nah, mesin itu pasti diharapkan menghasilkan barang sebanyak-banyaknya, tentunya juga dengan cost yang seminimalnya. Nah, cost. Nah, kemudian di breakdown terhadap availability, A, kita sebut A, kemudian performance, P, dan ataupun quality. Nah, dari sini mesin itu availability-nya berapa sih? Ketika kita punya mesin, kita jadwalkan jalan. Dia benar-benar bisa jalan, nggak bisa running bagus nggak ya? Atau kan nanti ada mesin tiba-tiba rusak. Nah, itu kita sebut availability. Kalau kemudian dari mesin itu berjalan, seberapa perform sih dia menghasilkan produk sesuai dengan standar yang kita butuhkan. Kemudian dari hasil yang dihasilkan, berapa bagus sih barang yang dihasilkan terhadap total produksinya. Nah, dari sini kemudian kita bisa eksplorasi banyak hal. Di OE dashboard kita adalah Pareto grafik, misalnya Pareto grafik. Downtime mana saja sih yang sering terjadi? Gitu. Kalau kita bicara IoT gitu ya, di mesin, IoT tahu kapan mesin itu mati, mesin itu jalan. Dia bisa counting berapa banyak mesin itu menghasilkan produk. Nah, tapi ketika kemudian ditanya mesin itu, mesin ini mati kena apa gitu ya? Karena apa? Nah, itu IoT belum bisa jawab. Nah, dengan adanya tadi di area operasional gitu ya, di edge control gitu, ada HMI, gitu, kita harapkan juga ada interaksi di sini bahwa human itu memberikan reason juga nih, kenapa kok mesin itu tidak berproduksi. Nah, dari reason itu kita harapkan juga nanti untuk ini ya, membuat decision maker ya. Kalau terjadinya Pareto terlalu banyak di A misalnya gitu, berarti kita harus bisa mengambil langkah B seperti itu. Nah, kenapa itu penting ya tadi? Karena kita bisa mengembangkan banyak hal dari sini. Yang pasti yang kita harus mulai adalah mesin dulu, dapat berbicara dulu nih. Kita counting aja mesinnya. Gitu. Nah, dari situ kita juga bisa tambahkan yang namanya parameter proses. Parameter proses itu apa? Misal, sebuah mesin ideal untuk menghasilkan es krim pada suhu -5. Nah, kita tambahin aja sensor untuk temperatur di mesin tersebut. Tanpa harus orang ukur manual atau kita harus melihat ke lapangan gitu. Berapa suhu mesin itu, ya dengan sensor tadi kita udah bisa membaca nih suhu operasional mesin ini. Kalau tadi saya sampaikan, kalau ada nilai yang tidak sesuai dengan standar, langsung kirim notif ke Telegram ataupun apapun itu, kita bisa lebih tahu lebih cepat. Oh, ini suhu mesin A nggak bagus nih, ayo tingkatkan lagi. Misal kurang dingin, ya berarti tambahin lagi pendinginnya, dan sebagainya. Itu parameter proses yang tadi kita implementasi juga di OEE ini. Dari situ ada istilahnya nanti statistik proses control. Itu juga lebih dalam lagi selanjutnya di implementasi OEE. Tapi harapannya tadi kita bisa melihat banyak gambar ya, banyak insight dari monitoring ini. Itu sekilas mungkin bisa lanjut dulu.
Iya, oke. Mungkin ini slide terakhir dari
Nah,
kami.
terakhir ya. Iya.
Slide terakhir gitu. Jadi
Tanya jawab aja nanti.
kita lanjut ke tanya jawab gitu ya. Kira-kira ada yang mau ditanyakan, saya kembalikan ke moderator.
Ya,
Siap. Terima kasih Mas Brian, Mas Fahmi. Wah, menarik banget. Jadi Pak Commerce dan juga partner ITDRI bisa banget kalau mau tanya ke Mas Brian maupun Mas Fahmi itu tinggal ketik di kolom chat sebelah kanan. Ya akan saya bacakan. Nah, ada 2 pertanyaan nih Mas Brian dan Mas Fahmi. Dari Putri, pertanyaannya, bagaimana pengguna IoT dapat memastikan keamanan datanya? Silahkan jawab Mas Brian dan Mas Fahmi.
Mas Fahmi duluan, monggo.
Oke, mungkin bisa dielaborasi keamanan data apa aja yang dikhawatirkan. Sebenarnya gini ya, kalau kita bicara data ya, tadi yang aku di aplikasi OE itu kan data counting gitu ya. Saya rasa sih untuk data itu yang pasti yang akan kita kirim ya yang terbatas kita butuhkan aja. Kayak data counting pada mesin produksi. Ya saya rasa masih aman-aman aja. Nah, tapi untuk mendukung keamanan tersebut pasti kita melakukan beberapa batasan ya. Yang tadi kalau kita di arsitektur ini ya, arsitektur yang tadi, yang pasti kita ya tambahkan firewall dan sebagainya. Kemudian kalau di ini ya di AWS tadi ada ini ya AWS Device Defender, jadi bahwa sensor tadi itu sudah di lock atau connectivity-nya sudah dipastikan satu arah dan itu sudah diberikan ya keys ataupun apapun itu sehingga dia bisa terhubung datanya gitu. Yang pasti ada layer-layer keamanan yang kita implementasikan baik dari sisi hardware, kemudian di sisi gateway-nya hanya bisa menerima data dari sini gitu kan. Kemudian dari sisi application juga pasti ada encrypted yang bisa kita lakukan terhadap data tersebut. Tapi so far sih sebenarnya menurut kami juga datanya nggak terlalu data urgent ya. Contoh implementasi IoT di ini ya kawasan untuk pencegahan banjir ya. Kan device-device-nya hanya mengirimkan ketinggian air aja gitu ya. Dan ID device dan sebagainya kan kita juga encrypt. Jadi saya rasa sih untuk keamanan masih acceptable lah seperti itu. Mas Pian mungkin mau menambahkan?
Ya, mungkin dari sudut pandang lain ya, terkait dengan security kan ada 3 hal ya. People, proses, ya, sama satu lagi teknologi. Tuh, yang tadi Mas Fahmi share itu kan terkait dengan teknologi ya. Tapi yang paling penting adalah people-nya gitu. Ya, people-nya memang perlu jaga ya. Nah, yang pertama standar lah ya, jaga password gitu ya. Sering-sering ganti password, itu gampangannya kayak gitu sih. Terkait dengan layer security yang paling standar yang bisa diimplementasikan gitu ya. Gitu sih. Standar sama kayak teknologi lainnya sih. Pasti acuannya 3 itu. People, proses, sama teknologi. Itu aja Mas. Kembali ke Mas Marcel. Silakan.
Oke, baik. Terima kasih jawabannya Mas Brian. Nah, ada lagi pertanyaan nih Mas dari Dino. Apakah tantangan Telkom ke depannya untuk industri IoT ini? Apakah lebih ke software, hardware, atau yang lainnya? Silakan jawab Mas Brian maupun Mas Fahmi.
Waduh, tantangan Telkom ya. Mau dibuka atau gimana? Gimana Mas Fahmi? Oke, mungkin yang umum aja ya, yang umum buat publik ya. Oke, tantangan dari sudut pandang apa dulu nih? Oh, dari sudut pandang market gitu ya. Dari sudut pandang market ya, dari pasar gitu ya, tantangannya memang terkait dengan penetrasi gitu ya. Penetrasi industri 4.0 itu akan berkembang sebanyak media ataupun informasi yang didapatkan oleh setiap customer ataupun user gitu ya. Jadi seperti yang aku ceritakan tadi ya, perkembangan industri itu seperti apa, academic paper-nya itu seperti apa, itu akan mempengaruhi juga informasi yang akan tersebar ke masyarakat gitu ya. Oh ternyata ini manfaat industri 4.0. Ada yang juga pesimis, oh industri 4.0 itu akan meng-cut banyak orang, akan mem-PHK banyak orang gitu ya di pabrik-pabrik. Nah, kita lihat dulu gitu. Nah, itu tantangannya di situ. Jadi antara literasi gitu ya, literasi terkait dengan industri 4.0 itu jadi tantangan juga gitu ya. Dan juga tantangannya mindset ya, lebih ke people ya, di customer ya. Kadang gini sih, aku pakai teknologi kamu, aku bisa nge-cut berapa orang. Nge-cut itu aku bisa mem-PHK berapa orang gitu. Itu kan ada hitung-hitungannya juga ya, return on investment gitu ya. Nah, itu juga jadi bahaya juga tuh kalau punya mindset yang kayak gitu. Itu jadi tantangan juga. Sebenarnya tantangannya lebih ke people-nya sih. Tapi kalau teknologi itu no issue ya. Telkom punya banyak sekali resource ya terkait dengan teknologi, dari segi talent juga sangat besar sekali gitu ya. Tapi di customer-nya terkait dengan mindset itu jadi tantangan terbesar buat Telkom gitu ya, buat mengadopsi untuk penetrasi IoT ataupun industri 4.0 gitu. Jadi kembali lagi ya, semakin berjalannya waktu juga akan membukakan pikiran dan mindset terkait dengan manfaat dari teknologi ini. Gitu. Mas Fahmi ada tambahan?
Ya, tambahan sedikit aja. Tadi disebutkan tantangannya apakah di software, hardware. Pada dasarnya semua tantangan itu ada gitu ya. Contoh kalau hardware ya tadi kalau aku tadi cerita terkait dengan connected device atau connected products, banyak jenisnya produk. Jadi kalau kita ada hambatan misalnya, mesin ini nggak bisa di-connection langsung gitu ya. Ya kita bisa tambahkan additional sensing. Nah, di sini juga kita bisa berpartner kan pastinya. Seperti itu. Atau pakai teknologi augmented reality atau camera vision. itu juga bisa membantu juga. Intinya challenge-challenge terkait dengan teknologi di hardware, software itu nggak menjadi isu sih. Jadi memang yang terlalu banyak isu di bagaimana kita bisa melakukan penetrasi terhadap teknologi ini, gitu. Kepada awareness dan urgensitas kenapa sih ini penting. Tapi kalau saya software, hardware, Telkom punya resource-nya lah, bisa macam-macam yang bisa dilakukan. Jadi saya itu sih mungkin tambahnya Mas ya. Balik ke Marcel silakan.
Siap. Wah, mantap banget nih dari jawaban dari Mas Priya maupun Mas Fahmi. Ya, bagi penonton dari Telkomers 44 untuk ITDRI, kalau yang masih kepo silahkan tanya di kolom chat sebelah kanan layar Anda. Nah, mungkin sambil menunggu pertanyaan-pertanyaan selanjutnya nih, Mas Priya, Mas Fahmi, aku mau tanya sedikit nih, kenapa sih orang-orang gitu ya tertarik belajar tuh bahkan inovasi itu mengenai teknologi IT saat ini? Gitu. Karena Mas Priya, Mas Fahmi.
Mau Mas Fahmi dulu kalau ini.
Boleh. Kenapa tertarik ya? Ya tadi, kalau kita berbicara misalnya nih di manufaktur gitu kan. Kendala yang banyak dihadapi orang itu adalah dia nggak tahu secara jelas, secara akurat ya, proses hari ini sebanyak apa, sebagus apa, dan sebagainya. Menjadi penting untuk kemudian kita bisa memaksimalkan productivity tadi. Contoh misalnya tadi membuat kembali lagi ke mesin. Sebelum adanya IoT gitu ya, ataupun monitoring real time, ya, PPIC ataupun planning di manufaktur tuh baru tahu nih produk A itu berapa sih dihasilkan sehari ini gitu, berapa yang reject dan sebagainya. Atau kemudian ketika bertanya, loh kenapa ini banyak produk yang reject? Oh nggak tahu Pak gitu. Nelusurinya itu menjadi costly gitu ya. Ketika kita tahunya terlambat. Itu tadi saya sampaikan, misalnya produksi ice cream kan. Ice cream pasti lebih butuh bagaimana temperatur itu dijaga di optimumnya kan gitu kan. Banyak reject, bisa jadi karena suhunya kepanasan dan sebagainya. Ketika kita bisa tahu lebih cepat gitu, tentu kita bisa menjaga mesin tadi efektif. Jadi makanya matriksnya di OEE-nya ya. Baik dari availability-nya kita lihat, kita monitoring, itu yang pertama. Kemudian yang pasti teknologi baru ya, IoT memudahkan kita banyak hal ya, yang awalnya kita nggak kepikiran. Biasanya teknologi diciptakan karena males ya, kita males kemudian diciptakan teknologi ya. Kalau kita lihat Mr. Bean itu kan, Mr. Bean itu kalau matikan lampu, lampunya ditembak, dor, karena apa, dia males untuk bangun gitu kan. Nah, sama kenapa tertarik di IoT pasti yaitu tadi, kemalasan itu kita solusikan. Matikan lampu males, ya udah kita konekkan aja lampu itu sehingga kita bisa jadwalkan nyala matinya gitu. Kalau kita jadwalkan nyala mati kan ya efektif juga listrik yang kita gunakan. Mungkin itu Mas Bian, mungkin ada tambahan Mas Bian, silakan.
Dari aku cukup. Dari Mas Marcel.
Itu ya. Jadi intinya menjawab kemalasan sih kenapa kemudian kita tertarik di IoT dan mudah-mudahan itu menjawab. Terima kasih.
Siap. Terima kasih Mas Priya, Mas Fahmi. Jadi memang orang-orang tertarik karena salah satunya menjadi solusi ya, kemudahan-kemudahan yang kita lewati setiap harinya gitu ya. Salah satu contohnya ya tadi males nyalain lampu atau AC atau TV itu bisa disolusikan melalui teknologi IT ini. Oke. Mungkin saya selanjutnya nih Mas, mari menunggu nih. Tadi kan kita berbicara tentang FOMO.id. Nah, kira-kira tuh boleh dijelasin nggak sih Mas produk IoT yang dikembangin FOMO saat ini itu apa gitu, terutama di tahun ini. Seperti itu Mas Priya, Mas Fahmi.
Oke, untuk yang kita kembangkan tahun ini ya, kita sebenarnya ada dua solusi ya. Yang pertama OII, yang satunya lagi IMS. Kalau tadi OII itu ibarat jantung yang ada di pabrik gitu ya. Jadi kita pengen tahu nih detak jantungnya pabrik itu seperti apa gitu ya. Kalau kita nggak tahu detak jantung tiba-tiba stroke gitu ya, wah pabriknya stroke, kemudian dia harus nge-lay off banyak orang gitu karena ya udah dia nggak bisa hidup lagi gitu. Contoh sederhananya adalah ketika kita tidak bisa memvisualisasikan availability mesin. Dia mati di jam berapa, dia nyala di jam berapa, persentase availability-nya berapa persen. Padahal pabrik itu ya, dia sudah mengeluarkan biaya gitu ya untuk listrik, kemudian untuk orang, tapi kok dia nggak memproduksi sesuatu gitu. Nah, itu bahaya tuh, itu bisa kena stroke gitu. Nah, satunya lagi selain monitoring jantungnya pabrik, satu lagi ada yang namanya IMS ataupun Environment Monitoring System. Itu ibaratnya kalau kita itu deteksi ginjal lah yang mensokong tubuh kita. Nah, kalau IMS kalau di pabrik itu lebih kayak suhu gitu ya. Suhu, contoh sederhananya kayak gini. Di industri kimia, suhu itu sangat sensitif gitu ya. Karena terkait dengan kualitas dari bahan baku. Dan itu sudah diatur juga di SOP maupun ISO. Nah, kalau tidak sesuai, maka bahan bakunya kualitasnya akan menurun. Kalau menurun, ya masa mau dijual di packing ke customer kan nggak mungkin juga gitu kan. Jadi yang FOMO lakukan adalah mengkombinasi untuk mendeteksi si jantungnya pabrik sama hal yang mensupport pabrik gitu ya. Contoh kayak tadi jantung, kalau ibarat manusia, yang satunya ginjalnya, ibaratnya gitu. Nah sekarang kita lagi di tahun ini kita memang pakai IoT semua gitu ya. Namun di tahun depan ini menariknya lagi ya, sesuai dengan data yang tadi ya, top innovation, 16% itu di artificial intelligence. Nah, FOMO di tahun 2023 akan mengarah ke sana juga ya. Kita lagi ngembangin machine learning juga. Jadi kita akan pakai kamera gitu ya untuk deteksi semuanya gitu. Jadi kita ngikutin tren yang ada di luar negeri juga gitu. Ternyata dengan kamera itu cost-nya itu lebih murah gitu dibandingkan pakai device sensor. Namun ini pasti akan di research dulu gitu ya. Cocok nggak dengan use case-nya? Kurang lebih seperti itu. Itu Mas, mungkin yang saya aku sharing.
Baik, wah ini banyak banget ya ternyata ya produknya dari FOMO ya Mas Brian, Mas Fahmi, ada OII, IMS, sama tadi yang saat ini sedang dikembangkan tadi teknologi menggunakan kamera gitu di Mas ya untuk machine learning gitu. Nah tadi menarik ketika ada pernyataan tuh sesuai dengan use case saat ini. Nah kira-kira tuh kebutuhan marketnya tuh kalau dari FOMO tuh fokusnya tuh di mana sih Mas Brian, Mas Fahmi? Mungkin bisa dijelasin biar
kalau dari segi market ya, segi market memang top industrinya memang industri manufaktur ya, karena perputaran uangnya paling besar di sana gitu. Nah, kalau agriculture sebenarnya kami pernah main juga, namun perputarannya kurang begitu sekencang yang di manufaktur gitu sih. Jadi sebenarnya FOMO saat ini memang fokusnya di manufaktur. Kalau IMS sendiri, produk IMS itu sebenarnya bisa diterapin juga untuk fishery, kemudian agriculture, dan juga poultry. Kurang lebih kayak gitu. Namun karena marketnya yang terus berubah, kami ngikut yang paling besar, yaitu yang di manufaktur. Itu, Mas.
Oke, Mas. Oh, berarti memang fokusnya di agriculture sama tadi manufacturing ya. Kira-kira kalau tadi ngomong use case tuh apa sih Mas use case yang paling sering terjadi gitu? Yang menjadi apa ya? Top list-nya FOMO gitu untuk bisa deliver produk customer. Silakan Mas.
Mungkin problem nanti bisa dilengkapi sama Mas Fahmi juga ya. The main problem adalah kertas ya. Banyak sekali kertas-kertas yang harus diinput ke inputer data gitu ya. Dalam artian gini, kertas di lantai produksi gitu ya, harus dicatat ini kuantitas, ini produksi shift sekian, operatornya siapa gitu ya, itu diproduksi oleh siapa, mesin apa. Itu kertas itu nanti diserahkan ke bagian input, dari input akan diolah datanya. Itu kurang agile gitu ya, atau kurang cepat gitu ya untuk mengambil keputusan. Karena data yang dari operator itu akan bisa diolah itu kurang lebih 1 bulan. Dan itu akan menghambat proses agile ataupun proses continuous improvement. Nah, yang FOMO lakukan adalah dengan adanya IoT tadi ya, kita pasang sensor gitu ya, supaya mengatasi kertas. Sekarang nggak usah pakai kertas gitu. Sekarang udah nggak usah pakai kertas lagi, nggak perlu input lagi, semua udah termonitoring, keluar grafiknya, sehingga teman-teman di manufaktur itu bisa fokus gitu ya. Di Pareto grafik itu ya, 6 big losses-nya itu apa gitu. Kendala terbesarnya apa sih, root of cost-nya apa gitu. Itu dalam hitungan menit itu udah keluar datanya gitu. Kalau tanpa FOMO ya kembali lagi. Ini nulis dulu di kertas, kemudian masukin ke Excel, baru diolah, habis itu kalau misalnya oke, masuk ke SAP gitu ya. Nah, itu prosesnya cukup panjang juga. Itu wasting time lah. Dengan adanya FOMO, semua bisa cepat gitu sih. Dan continuous improvement bisa cepat. Mas Fahmi ada yang mau ditambahkan, silakan Mas.
Cukup Mas Brian.
Tuh.
5 menit.
Siap, diingetin kita nih, 5 menit lagi. Mungkin terakhir, pertanyaan ya, buat Mas Brian, Mas Fahmi. Kira-kira apa sih harapan Mas Brian, Mas Fahmi itu mengenai perkembangan IoT di Indonesia sampai 10 tahun mendatang? Silakan Mas Brian.
Oke, terhadap ini ya, harapannya. Yang pertama dari dukungan pemerintah ya. Kalau kita lihat berkaca dari pemerintahan di Jerman gitu ya, mencetuskan industri 4.0, mereka punya roadmap yang sangat-sangat jelas sekali ya. Nah, aku harap juga Indonesia juga bisa seperti Jerman gitu ya, yang dimana punya strategic planning-nya. Dan harapan itu sebenarnya sudah mulai dibangun ya, ketika pemerintah itu mengeluarkan sebuah peraturan yang namanya INDI 4.0. Tetapi INDI 4.0 ini masih belum 100% gitu ya. Paling hanya 5% sampai 10% gitu ya. Hopefully bisa meningkat persenannya ini gitu terkait dengan INDI 4.0. Kalau dari aku kayak gitu Mas. Gitu. Mas Fahmi ada mau ditambahkan? Silakan Mas.
Ya, tambahkan sedikit aja. Ya, intinya dari tambahan berkaitan dengan keterbatasan ataupun resource ya, bahwa IoT itu pasti berkaitan dengan namanya device ya. Device bisa macam-macam. Nah, makin banyak orang yang nyoba-nyoba atau research untuk mengembangkan device-device ini ya. Kita di kamera sensing itu menjadi terobosan menurut kami ya. Misalnya ya itu tadi kayak sebelumnya counting mobil atau apa, kenapa nggak diimplementasi di manufaktur ya. Itu harapannya semakin banyak people di Telkomers juga mungkin bisa melakukan research di situ. Jadi tanpa hardware pun kita juga bisa mengkonekkan produk atau things ini ya terhadap use case yang bisa digunakan juga. Itu sih mungkin jadi lebih banyak teman-teman yang juga eksplorasi bagaimana menghubungkan device-device mereka untuk di follow up lah dengan namanya Internet of Things ini. Itu dari aku tambahan sekilas. Mas, terima kasih. Mas Marcel, saya kembalikan.
Baik, wah itu dari harapan dari Mas Brian dan Mas Fahmi mengenai teknologi IoT ini sebisa mungkin memang menjadi solusi ya ke depannya, terutama di Indonesia. Gitu. Oke, baik. Sudah diingatkan juga oleh tim gitu ya. Mungkin sedikit kita recap gitu ya mengenai topik pada siang hari ini, bahwa memang IoT itu sudah menjadi tren di dunia saat ini dan khususnya di Indonesia sendiri sedang berkembang. Dan salah satu yang hadir gitu di industri atau market IoT ini ada satunya FOMO yang memiliki beberapa produk yang bisa menjadi solusi bagi customer, yaitu ada OEI maupun iOS dan juga machine learning. Nah, mungkin itu yang bisa kita terima atau kita sampaikan gitu ya di sesi kali ini. Saya kembalikan ke Natasha, silakan.
Baik, terima kasih Mas Justian yang sudah memimpin sesi dengan sangat bermanfaat, dan juga kepada narasumber kita yaitu Mas Brian Ganda Pratama dan juga Mas Fahmi Hidayatullah yang sudah memberikan pemaparan yang sangat menarik dan tentunya sangat komprehensif. Gimana nih rekan-rekan, ada ilmu yang nambah nggak nih? Nah, tentunya ada banyak sekali ilmu dan insight yang tentunya dapat dibawa pulang oleh rekan-rekan sekalian pada hari ini. Nah, sekali lagi kami informasikan bahwa acara ITDRI ConFes 2022 akan berlangsung hingga tanggal 16 Desember 2022. Jadi rekan-rekan sekalian bisa ngajak siapapun untuk join di acara ini, biar acara ini semakin ramai dan tentunya semakin banyak ilmu yang bisa kita sebar ke masyarakat Indonesia. Baiklah rekan-rekan, sebelum mengakhiri acara kita pada hari ini, sebagai bahan evaluasi, kami mohon kesediaan rekan-rekan sekalian untuk dapat mengisi survei ITDRI yang berada pada bagian kanan bawah website icc.itdri.id agar ITDRI dapat terus berkolaborasi untuk mengembangkan learning, research, dan innovation. Dan demikianlah seluruh rangkaian acara kita pada hari ini telah selesai. Terima kasih untuk rekan-rekan yang telah hadir bergabung pada hari ini. Terima kasih juga atas partisipasi rekan-rekan semua. Saya, Natasha Gabriela Kastanya, pamit undur diri. Tetap sehat, selamat sore, dan sampai jumpa. Wassalamualaikum warahmatullahi wabarakatuh.